Hi guys, very good morning everyone and welcome to the session. And as you all know, very recently, just 2 days back on 2nd of August, HAL, the Navratna PSU, Hindustan Aeronautics Limited, has announced the recruitment for this year, and once again by the separate examination, okay, whose pattern you know, approximately 2.5 hours of examination. Okay, we've already given you the updates about the notification. Yesterday I took also a session on the strategy. Yes, what could be the 1 month preparation strategy for this particular examination. And today the team is going to come live to present you a mock test. And this mock test, what it is going to contain, let me tell you that this mock test will contain technical questions for EC. Of course, for common subjects, electrical students can also get benefited. So we're going to have 100 questions in this particular session. Yes, I repeat once again, exactly 100 questions we are going to have. So this is the first mock test, and all those, because exam is on short notice, just 1 month ahead, 9 September the exam is there. So it's right time to keep preparing and keep practicing the mock test and etc. So let's get moving ahead. Let's get started quickly. Yeah, so before I start up, quick update about a very important activity. Those who are willing to take the next step towards your success in the GATE examination, want to prepare under the best faculties of the nation, okay, and want financial assistance, right? You can get up to 90% scholarship, but you have to prove yourself in this national scholarship test, which is going to be on this Sunday, 6th of August, starting 9 a.m. You can register now on the BYJU'S exam prep app. Also, it's coming Tuesday. Yes, the coming Tuesday at 7:30 p.m. Me and Dheeraj Sardana sir together, we are going to come live for a free live mega interactive workshop again on the BYJU'S exam prep application, and we are going to present to you the topper's blueprint. Yes, the topper's plan, the strategy, the roadmap to get the success in the GATE examination. Right. So, what are some of the steps that can convert you into a GATE topper? That can convert you into a GATE topper, right? That's what we're going to talk about. So guys, now let's get started quickly share the session. I see very small motivation among the students right now, because it's just 1 month left. I think such mock test will be really beneficial for you. So quickly share the session to all your friends, and then let's get started quickly. Just a moment. Just a moment here. Okay, chalo. Right, you can get some notes on the app, Harshit. Yes, definitely. Chalo guys, so let's get started with question number 1. Acha, let me brief out something about the activities. Let me brief out something about the activities that we are going to cover up a total of 100 questions in this particular session, right? 100 questions will be there today in this particular mock test. Okay, so 100 questions, that means it is going to be technical. It is going to be the technical. That is what we are going to cover today. That is what we are going to cover today, because I hope you are all aware that the exam duration, right, if I talk about the HAL exam, it's a 2.5 hours examination that will contain 20 questions from general awareness, that will contain the 40 questions from English plus reasoning, right, and that will contain the 100 technical questions, branch specific. 100 technical questions that is going to be branch specific, right? Okay, so today we are going to cover up a complete mock test giving you the idea of those 100 questions. So let's have a look into it. Okay, I will be covering digital and EMFT. Okay, and digital computer and EMFT, and then Ashu Jhangra sir, Sanjay sir, Saket sir will join. We'll cover up all variety of questions that can be expected for an EC student. Okay, so what is the value of X in the following equation? Okay, what is the value of X in the following equation? So given a number system, my expected topic in these examinations, 21 in base X is equal to log of 11202 in base X to the base 2. Okay, log to the base 2. So just expand this. So what is 2x plus 1? What is 1 into base system X? So this is position 0, this is position 1. So 2 into x power 1 plus 1 into x power 0, that will be only written as 1. This is equal to log to the base 2. But what is the number? 11202 to the base X. So position 0, 1, 2, 3, 4. That is how you position. So 1 into x power 4. 1 into x power 3, right? 2 into x power 2, that is 2x square. Next is 0, and then 2 into x power 0. X power 0, no need to write. Okay. Right, now this is x power 4 plus x cube plus 2x square plus 2 is equal to, now this is eliminate the log, so you can take the 2 raised to the power 2x plus 1 on the other side. Okay, or it can also be written as twice of 2 raised to the power x. We can split 2 power 1 separately. Okay, now it looks like a fourth power equation. Okay, so please need not spend time in solving the fourth order equation. You can directly solve it by the options as well, right? You can directly solve it by the option. So if you try x equal to 4, I'll just go with the option by option. If you try x equal to 4, definitely guys have a watch here only. Okay, have a watch here only. What is going to be right hand side? Okay, 2 4s are 8. Okay, 2 4s are 8. Okay, so that becomes 2 power 8, 256 into 2, 512. But what is the value of 4 power 4? यहाँ पे आप देखोगे ना 4 power 4. What is 4 power 4? 4 को आप लिखोगे 2 power 2. ठीक है, 2 power 2 या 4 power 4 को अगर डायरेक्टली लिख लें, so that becomes 256 actually. 256. Okay, then plus 4 cube. 4 cube is 64. Plus 2 into 4 square, that is 2 into 16 plus 2. Is it equal to, that becomes 2 hours of 2 power 8, that is 256. This is clearly 500. It is not going to match. X equal to 3. X equal to 3 try karenge. Right, very, very good morning everyone. So if I try x equal to 3, right, so this is going to be 3 power 4, which is 81. Then 3 cube 27. 2 into 3 square, that is 2 into 9 plus 2. Is it equal to twice of, यहाँ पे x की जगह कितना रखना है? 3. Okay, so 2 power 6 and 2 power 6 is 64. Okay, does it match? So let me just calculate. This is 108, 110 and 128. Yes, this is definitely true because 64 into 2 is 128. Correct. So correct answer is D. And what is the pattern? Yesterday also in the session I told you, what is the pattern for HAL? It is MCQ question. Only one option correct. Only one option correct. Okay, yeah, ready. We are all, see, you know, HAL officially doesn't disclose the complete paper. We have some memory based question. We are collecting all of them actually, right? And once we collect all the memory based question of the previous year, we will bring you the HAL previous paper discussion as well. Right now it's a mock test, expected type of mock test that you can prepare. Okay, but exactly as per HAL level and all 100 questions to be covered up. Okay, ready. Okay, so the correct answer is option number B. Moving ahead to the next question, number 2 here. Okay, the irredundant minimized logic expression. Yeah, minimized of course means something again which cannot be reduced, the one and the same thing. Irredundant minimized logic expression corresponding to the K map shown below. Now, if you have studied these K maps, absolutely with concept, you must be able to recall. You must be able to, guess that this is one of the exceptional K map where we don't include the maximum largest possible group. Why? Because if you have to cover this minterm, if you have to group this minterm, there is only this pair option. Normally what you will think, normally you will start thinking about the squad. Normally you start thinking about the quad, but have a look into this. Again, what about this minterm? It can be paired. This minterm can be paired with the right one and this minterm can be paired with top. And if you make this 4 pairs, if you make the 4 pairs, now think, do you need the quad? Absolutely, you don't need the quad. You don't need the quad, right? Now, what is here? WX, that means 0, 0, W bar, X bar, 0, 1, 1, 1 and 1, 0. We all know that the K map follows the gray code. Okay, अगर यहाँ की बात करें 0, 0, W bar, Z bar, 0, 1, again 1, 1 and 1, 0, that is WZ bar. Okay, so what is this portion? This is both the places where W is high. X is high at the center too. So let me write down X here. Right. This is belonging to Y. Similarly, this belongs to Z. So what is each and every group? I'll just highlight in front of you. What is this? इसको देखेंगे. Right. Where is this group falling into? Right. This is outside W, above W, inside Y, inside Z. Okay. इसकी बात कर लेंगे. What is this? This is inside W and then X and then Y as well. Right. If I want to discuss about this one, very clearly this is in W, outside of Y, that is Y bar, and inside Z. Last but not the least, ये आ जाएगा above W, that is W bar, within X and outside Y, Y bar. Okay, so now correspondingly, we can match the option. Yes, definitely next we'll be preparing up the double E mock as well, Akbar, don't worry. Okay, we'll be preparing that. So इसको देख लेते हैं. What is my terms? W bar, YZ, WXY, W bar, YZ, WXY, ये यहाँ पे मिल गया, right? And then next, what do I have? Okay, W bar, XY bar, W bar, XY bar, W bar, XY bar, and WY bar Z. WY bar Z, yes, option number B. all the terms that I have selected is matching with the option number B. Okay. Yes, probably you can expect for HPCL as well, Bharat. Okay. Chalo guys, come on, quickly keep sharing the session, and yeah, do not forget to like. Put your attendance, guys. The number third question is here. Okay. If 211x is equal to 152 in octal number system, base 8 is octal number system, what is the value of the base x? What is the value of the base x? Come on, everybody. Again, the simpler one. And HAL you'll expect mostly simpler one only. But abhi aur variety cover karenge. So 211x, right? 211x. Again, position 0, 1, 2. Right? So 2 into digit into base power position. Base is x, so base square. Plus 1 into x power 1. Plus 1 into x power 0. X power 0 is 1 only. Okay, next. Now again position 0, 1, 2. 1 into 8 square. Next is digit 5 multiplied by 8 power 1. Next 2 into 8 power 0. That is simply 2. Okay, ji. So how much is this? So I get an equation 2x square plus x plus 1 is equal to 64 plus 40. Okay, plus 6, that is 106. Or you can write down this equation as 2x square plus x minus of 105 is equal to the 0. Right? Okay, now we can find out the value of the roots from here. So what is going to be the value of the roots? X is equal to -1 plus minus root over b square. Okay, minus 4ac. So when I write down minus 4ac, 4 into 2, 8, 840. This will become plus 840. Minus minus plus divided by 2a. So what is the value of x? -1 plus minus under root of 841. Under root of 841 will be 29. Divided by 4. So 29 minus 1, 28 by 4, 7. And next is minus 30 by 4, minus 7.5. X is equal to base. Base cannot be negative. Base only has to be a positive, and that too integer. Right? Okay, because it is base. Because it is base, it has to be positive integer. Okay, and that is why x is equal to 7 will be my final answer. X equal to 7, my final answer. That is option number D. That is the option number D. ठीक है जी. चलते हैं next question की तरफ. Okay, the resolution of a DAC depends on which of the following? Definitely the resolution depends on the number of bits. The resolution of a DAC depends on the number of the bits. Okay, so some questions, देखो, you might be thinking, what is the pattern? 150 minutes and 160 questions. Okay, but okay, no, that will not be virtual, will not be there, Akbar. So some questions may take little calculation. This is little, but then there will be some questions which do not take any calculation. If you know, you can answer, otherwise you can skip it. That's what. Okay, so don't worry, it will be balanced. You should be able to solve most questions in this 150 minutes. If x and y are the logic inputs, and they are available, and their respective complements x bar, y bar not available, then the minimum number of 2 input NAND gates required to implement x XOR y. Number of NAND gates required to implement AND gate, NOT gate, OR gate, XOR gate, XNOR. This should be known to you. Right, we will take one more question in this mock test where we will find out by method. Okay, but for the standard gates, you should know it. For NAND, for XOR gate, it is 4. For XOR gate, it is 4, right? NOT के लिए, how many NOT? NOT के लिए 1. For AND gates, you need 2 NAND gates. For OR gates, you need 3 NAND gates. For XOR gates, you need 4 NAND gates. For XNOR gates, you need 5. So these are some things which should be there in your notes. Okay, that's why I don't want to draw the diagram in detail. Okay, I have discussed this once. I have taken detailed sessions on the NAND and NOR gates. Moving ahead to the next. Now this is something you have to solve. That's what I'm telling. Some questions we solve karenge. Some questions directly we can approach. Right? So the circuit shown below implements a 2-input NOR gate. So this entire circuit is going to implement a 2-input NOR gate by using 2 2x1 multiplexer. What is the value of ABC respectively? What is the value of the ABC respectively? I want a NOR gate. Right? What I want is x plus y, NOR gate, x plus y whole bar, which can also be written as x bar, y bar. Now let's see in what form I am able to implement. Acha, let us say the output of this particular first multiplexer is F. Okay, so what is going to be F? Have a look into this. What is going to be F, dear? F is going to be, select line is C, right? So C bar pe aayega I naught is y. Plus C, when C is equal to 1, at C you will get I1 which is equal to x. So plus Cx, that is the value of F. Acha ji. Now, what is the value of ABC to make that particular function coming up? And if you notice the option, you have to be smart. If you notice the option, okay, A is either 0 or 1. Right? A is either 0 or either 1. So, ek se try kar lete na, maybe it works out very simply. So, if I start with A equal to 0, right? if I start with A equal to 0, what is the value of Z? The output of the multiplexer. The output of the multiplexer, select line pe aa raha hai F. Okay, so F if 0, F bar into I naught will be B, right? Plus F into A, but A ko maine 0 le liya, so this is F bar into B. Okay, so I've got a product term. ठीक है. Now very very simply, अगर आप options में देखोगे तो 0 के साथ you have X bar also as an option. Okay, so if I try that B is equal to X bar, so what is the Z now? F bar into X bar. F bar into X bar. That's what I'm looking for, X bar, Y bar. So only thing is, अगर F को Y बना दिया, my problem is solved. How can F be equal to Y? How can F be equal to Y? Right. F can be equal to Y if this term is eliminated. That is, if C is equal to 0, isn't it? Agar C ko 0 kiya, this term is eliminated. C bar is 1, so 1 into Y will be 1. F will become Y if C is equal to 0. That means Z will become F bar, but F is Y now, so that is Y bar, X bar, and that is what is implemented. Right. So C should be 0. Okay. B is X bar and A we tried 0. Right. So 0 X bar 0 is the correct answer. 0 X bar 0 is the correct answer. So in these exams, you have to develop this smart approach to solve MCQ questions as well. Okay, to be handle MCQ questions with the options. Okay, with the variety of options. चलते हैं next question की तरफ. The resolution of 10-bit analog to digital converter in percentage. Right, in percentage. What is the percentage resolution? In percentage, the resolution is given by the formula 1 upon 2n, 1 upon 2 power n minus 1, 1 upon 2 power n whole minus 1 into 100. Percentage mein hai, so we don't need any full scale level and all. That is eventually cancelled. So what is that I can write down? Okay, 1 upon, so 1 ki jagah 100 hi likh dete hain. That is eventually 100 divided by 2 raised to the power how much? I have a 10-bit DAC. Right, so 100 divided by 2 power 10, 1024. Minus 1023. So what should be the correct answer? See, if it was 1000 to 0.1, something less than 0.1. Okay, something slightly less than 0.1. Okay, even if you are going without calculator, देखो ना, if I approximate this to 1000, तो 100 upon 1000 is 0.1. Denominator slightly bigger, answer slightly smaller. तो 0.1 से थोड़ा सा छोटा 0.097. Okay, थोड़ा सा छोटा only. Right, थोड़ा सा छोटा. तो approximately 0.097. We can do it directly. Approximately 0.097. Hope that is correct. 0.097. चलते हैं next question की तरफ. Yes, Chinmoy, correct answer. 8th one. In 8085 processor, if the clock frequency is 5 megahertz, what is the time required to execute an instruction of 18 T states? Now, what is the time required to execute 1 T state? Is 1 T clock, right? For 1 T state, very fundamentals of processor. Okay, is 1 T clock. Right. So what is the time required to execute an instruction of 18 T states will be equal to 18 T clock. Right. What is the T clock? Clock frequency is given. What is the time period of the clock? Time period is 1 upon clock frequency. That is 1 upon 5 into 10 power 6. 10 power 6 को ऊपर ले लेंगे. Right. Options is in microseconds. So 1 by 5 is 0.2. 0.2 and then microseconds. 10 power minus 6 is microseconds. So this becomes how much? 18 into 0.2 microsecond. That is going to be 36. 3.6 microsecond is my answer. 3.6, option number B. Right, dear? The very correct answer is option number B. The very, very correct answer is option number B. Done. 3.6 microseconds. Okay, next one. Which logic gate is used to detect overflow? Again, I'm telling you na, some questions में fundamental calculation. This ये तो बहुत ही basic calculation था, right? Some questions are directly which you know, which you have studied while studying the digital circuits. Okay, for overflow, XOR gates are used. Okay, ultimately it boils down to XOR gate because you have to have the comparison of the bits. ठीक है, चलिए. Okay, you have to have the comparison of the bits. Okay, whenever the MSB, whenever the sign bits of the numbers to be added are different, there cannot be overflow. Only if they are same, overflow possibilities occur. So that is why XOR comes into the picture. 10th, following logic gate is equivalent to, very simple question, right? This is a NAND gate, both the input shorted. That is, it is an inverter, A bar. This is B bar, right? Now what is this? right? This is again a NAND gate, A bar, B bar, whole bar, right? What are the inputs? A bar, B bar. So A bar, B bar ka whole bar. But again, this is going to complement this. So this is A bar, B bar. Whole bar ka bar cancelled because this is again an inverter. Okay. NOT gate. This is also NOT. NAND gate, both input shorted is NOT. Okay. So A bar, B bar. A bar, B bar by De Morgan's is A plus B. So it is a NOR gate actually. It is just a NOR gate. It is nothing but a NOR gate. Clear everybody? Hanji. It is a NOR gate. Done. Next question. The minimum number of two input NAND gates required to implement a Boolean function x bar plus y bar into z plus y. Okay. Now, one of the question we took, minimum number of two input NAND gates required to implement what? Required to implement NAND gates. There we took the direct answer. Because I'm telling you, number of NAND and NOR gates required to implement the basic gates like AND or NOT or the special gates like XOR, XNOR. Ye pata hona chahiye directly. This should be there in your notes. Okay. Now, for any other functions, okay, we can do this. But यहाँ पे थोड़ा सा इसको simple करेंगे, logic apply करेंगे. X bar plus Y bar, right? X bar plus Y bar by De Morgan's. X bar plus Y bar is simply X into Y whole bar. And X into Y whole bar is directly NAND gate. So if there is a NAND element already available, we can use it directly, na? Okay, rest it is OR gate or multiplication means AND gates. That has to be converted to NAND. So XY whole bar into Z plus Y. Z plus W, sorry. Right? Or I can split this as XY whole bar into Z plus XY whole bar into W. Right? Now XY, that's what I'm telling. XY whole bar is already a NAND gate. XY whole bar is already a NAND gate. This is X, this is Y. Now it has to be multiplied by Z. That means an AND gate will come up here. An AND gate will come up here. And then it is to be multiplied by, W. Right. Then it is to be multiplied by W. Okay. And now it is to be added. That means OR gate. That means it is to be added. That means it is the OR gate. That is the F. Now this is using the basic gate. इस circuit को आपको complete करना है and you have to tell me the number of NAND gates. One is definitely sure. Now what is the procedure, guys? We know. Okay, to convert any circuit into NAND gate structure, what I need is I will place the bubbles at all the AND gate outputs. जितने भी AND gate हैं उन सभी के output पे bubble आएगा, bubble it up, and place the bubbles at the OR gate inputs. At all the OR gate inputs, I will place the bubbles. At all the OR gates input, I will place the bubble. ठीक है? चलिए. Now, whenever bubble are in series, so they automatically cancel each other because bubble is like adding an inverter. Right? If you add a single inverter, it will affect the answer. But you have added two inverters in series. So series inverter cancel each other, nothing to be done extra. Similarly, ये भी series हो गया. So this is also cancelled. Okay. Now, by adding the bubble, this AND gate become NAND gate. So how many NAND gates? This is 1, this is 2, this is 3, right? This is 4. Okay. Whenever there are bubbles at the input of OR gate, that is also a NAND gate, na? Hey, what does it mean? Hey, what does this mean? This is A, this is B, right? And it is a input A bar and B bar then, and it is OR gate plus. But what is A bar plus B bar? It is AB whole bar. That is also a NAND gate. Okay. So bubble at the output of AND gate or bubbles at the input of OR gates. Both of them are known as NAND gates. Both of them are the structures of NAND gate. So this is also a NAND gate. Total 4 in number. Correct answer is D. Correct answer is equal to D. Moving ahead to the next question. A certain 8-bit successive approximation type analog to digital converter has full scale voltage of 2.65. If the conversion time for VA is 1.5 volt is 75, okay, then the conversion time for VA is equal to 2.5. See, what type of ADC it is? Successive approximation type, right? For successive approximation resistor ADC, right? जो भी conversion time है, it depends on what? Does it depend on the VA? Okay, has the full scale voltage of 2.65. Now the input to be converted is 1.5 volt and second is 2.5 volt. Does it depend on the VA? Right, for SAR it depends only on the V full scale, right? V full level, right? That means if it is 75, it will be 75 only. Okay, if it was counting type, देखो next type of question बन सकता है इसमें counting type. If it is counting type ADC, right, then the conversion time definitely depends on the input to be converted. Okay, it depends on the analog input VA. There it depends, right? But here it doesn't depend. So whether it is 1.5 or 2.5, okay, it remains same because it is the same ADC with the same full scale specified as 2.65. That is what matters. Okay. इस पे depend करेगा. So for both the cases it is 75 microseconds. Option number A is correct. Okay, so see that this is what conceptual and knowledge based question. If you have studied SAR, you must know it. Okay, otherwise we might think यार यहाँ तो कुछ calculation है and no, nothing required like that. Number 13. 24 megahertz clock frequency is applied to a cascaded counter of mod 3, mod 4, mod 5. The lowest output frequency and the overall mod value of the cascaded counter. Lowest output frequency and the overall mod value of the cascaded counter. Now, overall mod value kitna hota hai? Whenever counters are cascaded, the mod numbers are multiplied actually. Okay, so this becomes 12, 12, 5 is 60. Okay, so mod number to 60 hoga. And then the lowest output frequency is obtained at the MSB. Right, as the MSB of the overall cascaded connection. Okay, the frequency at MSB. Okay, the lowest output frequency is the frequency at MSB, and that is given by the clock frequency that is applied divided by the total modulus number. So what is the clock frequency applied? 24 mega, that is 24 10 power 6 divided by 60. So this is cancelled as 40.4. So isko likh denge 400 10 power 3 will be a kilohertz. So 400 10 power 3, so 400 kilohertz. Option number B. Option number B, right dear? That is known as the option number B. Chalo, done hai, correct. That is the option number B. Moving ahead to the next. A SR flip-flop is converted into X flip-flop as given below. Is converted into a X flip-flop as given below. Right, what is the characteristic equation? Now, what is the characteristic equation for a SR flip-flop? Pehle wo pata hona chahiye. What is the characteristic equation for a SR flip-flop? So for a SR flip-flop, the characteristic equation is given by Qn plus 1. Okay, is S plus R bar Qn. S plus R bar Q. S plus R bar Q. Now what is there on the R? Now see, this Qn comes to this, what is this? This is a XNOR gate used in front of you. This is a XNOR gate used in front of you. So यहाँ पे आ जाएगा X XNOR with Qn. Right. Now we are going to take the complement of it. तो complement लिया तो यहाँ पे क्या आ जाएगा? यहाँ पे XOR आ जाएगा. X XOR Qn. X XOR Qn. So what is there in place of S? Right. X. What is there in place of S? That is going to be X. Yeah, let's make it little bit simpler. अभी इसको हम ऐसा करते हैं. Suppose, okay, suppose this is some variable. इसको मैंने बोल दिया Y bar. So this will be Y and Y bar comes here. Okay, this will be Y. Okay, so what is this? S की जगह आ गया Y plus R bar, right? R is Y bar, so R bar will again be Y. So Y plus Y Qn, and that is why it becomes simple. Y को ले लिया common, 1 plus Qn. So what is the next state? Qn plus 1, it is equal to Y. Now what is Y? Y bar is the output of XNOR gate. So Y means it will be the XOR, that is X XOR with what? XOR with Qn. X XOR with Qn. X XOR with Qn. Right, option number C. The correct answer is option number C. Yes, Ashwar, correct answer. The correct answer is option number C. Now, actually, if you think this is the conversion of SR flip-flop into what? X XOR Q. It's like T XOR Q. It is just like a T flip-flop. This is the characteristic equation. देखो नाम में तो कुछ रखा नहीं है. We use T to name it as toggle. But ultimately it is a T flip-flop. When the name is like X or Y or Z or T or A or B, doesn't matter. नाम में कुछ नहीं रखा है. But if you eventually look, it is a T flip-flop. Okay, if I name this as T, it's a T flip-flop. That's it. Okay. Chalo, done hai ji. Next question here. The initial output of the following circuit is 1. Okay. If we apply 0, 1, 0, 1, 0, 1 at the input, okay, then what is the bit pattern generated at the output Y? Okay. Right. ठीक है, the first bit is 0. यहाँ से start किया 0, 1, 0, 1, 0, 1. Now initial output is 1. Now look into this. It's a cascaded structure of 3 XOR gates. Cascaded structure of 3 XOR gates, and one of the input to all the XOR gate is fixed at 1. So ये कितना हो गया? This is A XOR 1. Right, this is known as the A XOR 1. What is A XOR 1? A XOR 1, it is known as A bar. A bar into 1 plus A into 1 bar. That is A bar. Now what is this? Okay, now the input is A bar, but another one is still 1. Okay, A bar XOR 1 will again become A. Whatever variable you XOR with 1, uska complement aa jayega. Now, once again, what is the output? Y then? Okay, the input once again is A, and A again XOR with 1. A again XOR with 1. Output is again A bar. So, final output is A bar only, and there are no delays involved. Delay pe hai nahi. Okay, so whatever input bit you apply, output is a complement of it, right? So, when you apply 0, 1, 0, 1, 0, 1, right, this is the input bit you apply. This is the bit that you apply at A, right? What is going to be the Y? It is a complement, so it should be 1, 0, 1, 0, 1, 0. 1, 0, 1, 0, 1, 0. So B. It will get the answer as B. You get the answer as B. Clear, everybody? Yes, it is going to get the answer as B. Yes, Ashwar, correct answer. The final correct answer is equal to what? Is equal to the B. Yeah, done. Next one, dear. The optical performance monitoring involves, okay, transport layer monitoring, optical signal monitoring, protocol performance monitoring. Okay, see, something related with networking. Okay, something related with networking. Although for this year, they have specified that the syllabus is going to be copy of K 2023. Maybe such questions not included, but hota hai. That's what electronics mein yesterday also I told you. There are some elements of computer or microwave engineering, especially they keep asking. Okay, so you must be prepared about this. So that's why just one question I have put. The correct answer for it is A. Okay, let's need not discuss it. The answer will be A. Okay, but just in case we have included like microwave, computer engineering, especially for electronic students, 1 or 2, and then measurements also. इस तरीके से कुछ questions deviate हो जाते हैं. Okay, basic fundamentals of measurement. So you must be prepared about that, as I specified in the yesterday strategy session also. But how to focus those topics, वो भी मैंने बात किया था, when and how to focus. Next one, moving ahead to the EMFT. Okay. Right. The point charges Q1, Q2 are located at 2 to 0, 0, 0, minus 1. What is the electrostatic force between them? And see, there is no direction involved. Okay, it is only the force. There is no direction involved. Direction पूछते तो वो भी निकाल लेते, not a big deal. But they are only asking the force. So we can write down that force as K Q1, Q2 is divided by R square. Okay, as K Q1 Q2 divided by R square. Now, of course, we'll assume it to be free space. So K will be 9 into 10 power 9. Okay, multiplied by Q1 minus 1 microcoulomb. That is minus 1 into 10 power minus 6. Q2 is 3 microcoulomb, 3 into 10 power minus 6. And divided by R. R is the distance between them. So what is going to be the value for R? R is root over of x square plus y square plus z square. Root over x2 minus x1 whole square plus y2 minus y1 etc. Distance formula apply करेंगे तो 2 minus 0 whole square. Again 2 minus 0 whole square. और last में आ गया 0 minus minus 1 तो 0 plus 1 whole square. That is eventually root over 9. 4 plus 4 plus 1. Okay, वैसे भी हमें r square चाहिए तो r square will be 9. 9 and 9 get cancelled. It is minus 3. It is minus 3 and 10 power minus 12. एक 10 power minus 3 बचेगा. So minus 3 millinewtons it is. Minus 3 millinewtons. Option number A. The basic question on Coulomb's law. Right. ठीक है. Yes, Mohan will come up with some more additional courses as well and series. Next चलते हैं. Number 18. A very fundamental expected question. Chinmay check कर लेना. It is A, not B. A 10 megahertz uniform plane wave propagates through a lossy medium so that its amplitude is reduced by 20% every meter traveled. Amplitude reduced by 20% every meter traveled. Right. Now, what is the amplitude formula in general? This amplitude is given by the formula initial amplitude E naught into e raised to the power minus alpha z. Whenever I distance 1 meter, every meter, whenever z is equal to 1, the amplitude becomes how much? The amplitude becomes, it is reduced by 20%, right? So it becomes 80%. 20% घटा तो बचा 80%. 80% is like 0.8, right? 0.8. Okay, 0.8, right? So I have 0.8 E naught is equal to the E naught, e raised to the power minus alpha z, but z is equal to 1. Okay, so e power minus alpha is 0.8 या e raised to the power plus alpha लेंगे, reciprocal करेंगे तो 1 upon 0.8, that will be 1.25. So what is going to be the alpha? Alpha will be ln 1.25, and then I want the skin depth. What is the skin depth? What is the skin depth? It is given by the formula 1 upon alpha. The skin depth is given by the formula 1 upon alpha. तो ये कितना हो जाएगा? A quick calculation if I just want to complete here. So this is turning out to be 0.22 approximately, and then 4.48. 4.48 meters will be the final skin depth. Option number B. Okay. Yes, what are the important topics, Ghosh, for GA? What can be the expected topics for GA? I told you in the yesterday's session, and yeah, we'll try to plan up some sessions for GA as well. Okay. चलते हैं next question की तरफ. A lossless transmission line, okay, having the characteristic impedance of 100 ohms is terminated by a load resistance RL. If the voltage standing wave ratio is 2, what is the value of RL? Dekho, now standing wave ratio, when both the impedances, okay, the line impedance as well as the load impedance, when both of them are real, standing wave ratio has the direct shortcut formula, which is given by RL by R0 or R0 by RL. Okay. The standing wave ratio is just equal to the ratio of both the resistance if they are real. If they are not real, then we have the general formula for standing wave ratio, that is 1 plus mod k upon 1 minus mod k, where k is the reflection coefficient, ZL minus Z0 upon ZL plus Z0. But for all the real resistance, this is the formula. But which is the formula? It depends. If RL is greater than R0, see, standing wave ratio is always greater than 1. You can remember like this. So RL, okay, greater than R0. Okay, so RL will be in the numerator, right? If R0 is greater than RL, R0 will be in the numerator. Numerator should be bigger. But यहाँ पे कुछ नहीं बोला है. There is a load resistance RL, but whether it is greater than 100 or less than 100, there is no such information mentioned here. There is no such information mentioned here. So that means here standing wave ratio, which is 2, can be equal to R0. पता है मुझे. What is this? This is the R0. So it can be RL by 100, or it could be 100 divided by RL. So what is the value of the RL? Okay, it could be either 200, right? Or second formula se jayenge, it could be either the 50. Okay, so option number C will be the appropriate one here. Option number C will be appropriate one here. Right. Chalo, option number C will be appropriate. Next question ki taraf move karte hain. 20. A lossless medium has epsilon R and mu R given to you. What is the intrinsic impedance? Okay. So both relative permittivity and permeability are same. Okay, so वो cancel हो जाएंगे because the intrinsic impedance of the medium eta is given by the formula root over mu by epsilon, right? So mu is how much? 4 mu naught. Epsilon is 4 epsilon naught. So this is simply root over mu naught upon epsilon naught. That is the impedance of free space also. And what is the value? See, again you can calculate, but standard data known hona chahiye. What is the velocity in free space? What is the impedance of free space? So impedance of free space 120 pi. 120 pi. अच्छा 120 pi और 377 ये दोनों वैल्यू पता होना चाहिए. Okay, it is 120 pi or 377 ohms. Option number A. That's it. Okay, so ये तो वैल्यू पता होनी चाहिए. ठीक है जी, डन है. Next one. An air-filled rectangular waveguide has a dimension A 2 cm, B is 1.5 cm. A waveguide is operating at 15 GHz with the TE01 mode. What is the corresponding phase velocity? Okay, of course, for the phase velocity, we need the cutoff frequency first of all. So what is that cutoff frequency for TE01 mode? For TE01 mode, it is given by U dash by 2. U dash is the velocity in the dielectric, in the open dielectric. ये air-filled है, right? ये air-filled है, तो U dash will be C. Air-filled means the dielectric inside the waveguide is air. So what is the velocity of any wave in the open air? If it was an open air, then it is C, 3 into 10 power 8. वो बाद में रख देंगे. U dash by 2 into U dash by 2 B. Because the general formula for cutoff frequency is U dash by 2 root over of M by A whole square plus N by B whole square. That is a fundamental formula if it is TEMN modes or TMMN as well. ठीक है. So यहाँ पे आ जाएगा t is 0 1, m is 0, n is 1, तो 1 by b का square under root से cancel होके only 1 by b, right? That is the cutoff frequency, right? So what is that? If I just start evaluating it, so that cutoff frequency is now going to be u dash is c, that is 3 into 10 power 8 divided by 2 into b, and b is 1.5 centimeter, 10 power minus 2, तो ये 3 cancel हुआ. So FC is turning out to be 10 power 10. 10 power 10 is nothing but 10 gigahertz. Now what is the phase velocity? Phase velocity VP is given by the formula once again, that is U dash. Okay, phase velocity VP or UP, once again it is U dash upon under root of 1 minus FC by F whole square. So this is going to be U dash, which is again 3 into 10 power 8 whole divided by root over 1 minus FC. Cutoff frequency 10 gigahertz. Operating frequency is 15 gigahertz. So they would cancel each other. Giga cancel ho jayega. So this is going to be 3 into 10 power 8 divided by 1 minus 2 by 3. Okay, so 1 minus 4 by 5. Right, kitna aa jayega ye? 1 minus 2 by 3. 2 by 3 ka square 4 by 9. Is 4 5 divided by 9 under root 9 3, 9 divided by root 5 approximately कर देंगे हम. Okay, 9 divided by 2 point something, I think ये 2 point something ही आ जाएगा. तो D has to be the correct answer, right? D has to be the correct answer. Approximately I am able to say. नहीं यार, D नहीं होना चाहिए. I'm sorry, I think I have done some calculation error. 1 minus 4 by 9, कहाँ मिस्टेक हुआ है? 1 minus FC by F whole square, 2 by 3, that is 4 by 9, 9 ऊपर गया 3, 9 is divided by root 5. So it's going to be, नहीं 3 भी नहीं होगा. I think some data is not perfect here. मुझे ऐसा डाउट हो रहा है, data is not perfect here. Just a second, let me check on the numbers. 4, approximately 4 आ रहा है, sorry, yeah. Approximately 4 is turning out to be. ओके चलो ठीक है यार, कैलकुलेशन हो जाता है कभी कभी. सो 4 अप्रोक्सीमेटली 4 आ जा रहा है. दैट्स नॉट अ बिग डील. ऑप्शन नंबर ए. ऑप्शन नंबर ए. सॉरी, इट हैज टू बी 4. 2.24 into 4 करेक्ट. अप्रोक्सीमेटली 4 आ रहा है. ठीक है, डन. इट्स ए. करेक्ट आंसर घोष, इट इज ए. डन है. नेक्स्ट आ जाते हैं. सो इट इज ऑप्शन नंबर ए. नेक्स्ट क्वेश्चन हियर 22. An antenna has a diameter of 1 meter. It's operating at 1 gigahertz. Minimum distance beyond which the inductive and electrostatic contribution of the radiated fields can be neglected, and that distance is known as the far field distance. Okay, that is the far field distance. So this question is asking actually what is the far zone. Okay, and far zone is defined by the distance which is greater than 2d square by lambda, right? So what is that minimum distance? Okay, is given by 2d square by lambda, where d in general is not diameter, but d is the largest dimension of the antenna, but here that is given to be diameter. ठीक है, what is the lambda? What is the lambda? Lambda अलग से निकालेंगे. Lambda is given by c by f, that is 3 into 10 power 8 upon operating frequency. So lambda is 0.3 actually, right? So this is going to be 2 into d square. D 1 है, largest dimension, divided by 0.3, right? So 2 by 0.3, 6.67. Okay, it is going to be 6.67 meters as the answer. It is going to be 6.67 as the answer. Done है. Option number B. Done है. Next again, the far zone of an antenna, where D is the largest dimension. So this antenna might be having a circular front, maybe like a reflector antenna. Next question की तरफ move करते हैं. A TE10 rectangular waveguide is to be designed for operation over 25 to 35 gigahertz, and the band center is 1.5 times the cutoff frequency. What should be the dimension of the broadside? Okay, देखो क्या बोला है. TE01, the mode is TE01. It is to be designed over 25 to 35, and the band center. What is the band center? कितना हुआ center? Okay, the band center will become 25 or 35 का center, 30 gigahertz. Okay, this is 1.5 times the cutoff frequency. Okay, so what is the cutoff frequency? 30 by 1.5, 20 gigahertz हो जाएगा. Cutoff frequency, right? Now, the cutoff frequency for TE10. The cutoff frequency for TE10. Of course, when nothing is mentioned, okay, U dash will be C. Air-filled waveguide होना चाहिए वो. It has to be air-filled waveguide. Okay, so what is this? Okay, cutoff frequency. This is going to be 3 into 10 power 8 divided by 2a. right? The cutoff frequency U dash by 2A for the dominant mode, for the TE10 dominant mode. Formula already I showed you in the previous slide. This is 20 gigahertz, right? So यहाँ से आ जाएगा ना, what is the value of A? From here you can calculate what is the value of A. This is going to be 10 power 8 cancel, 3 by 4 0.75 and then 10 power minus 2 or 0.75 mm के form में given है, no problem. So divide and multiply by 10, 7.5 mm. 7.5 mm, it is D then. It is option number D. Yes dear, option number D, 7.5 mm. 7.5 mm. Move करते हैं. The relation between the magnetic vector potential and the magnetic field intensity. See, the magnetic vector potential, curl of A. For the magnetic vector potential, the curl gives the magnetic flux density B. B is del cross A, right? But B is equal to what? B is equal to mu H. B is known as mu H, that is del cross A. So what is the value of H? 1 upon mu del cross A. What is the value of H is 1 upon mu del cross A. Right, the fundamental, again, definition or factual question. 1 upon mu del cross A. That is 1 upon mu del cross A. Option number A. 1 upon mu del cross A. Done. Next. A microstrip line of 50 ohm is terminated in 40 plus J30. What is the VSWR of the load? What is the VSWR of the load? Okay. Now here both the impedances are not real. Okay, so we can't use that RL by R0, R0 by RL formula. Okay, so what is the VSWR on the line? VSWR is generally given by the formula 1 plus mod KL upon 1 minus mod KL, where KL is known as the load reflection coefficient. Okay, KL is the load reflection coefficient, which is given by the formula ZL minus Z0 is divided by ZL plus Z0. And what is the value of ZL? That is 40 plus J30. ZL minus Z0 or Z0 हो गया 50 divided by 40 plus J30, 40 plus J30 plus of 50, that is ZL plus Z0. तो कितना आया? minus 20 plus J30 is divided by 40 plus 90 plus J30, या simplified form में हम लिख सकते हैं minus 2 plus J3 upon 9 plus J3. ठीक है. Now, what is the value of? ये हो गया KL का value, right? Okay, so need not simplify it. Okay, need not find the final value. Just calculate the magnitude, na? And magnitude of complex number root over x square plus y square. दोनों पे root apply करेंगे. The denominator 2 square plus 3 square. Numerator denominator 9 square plus 3 square, right? So it is under root of 13 is divided by 90. Okay, so you have to just calculate this number fundamentally and we'll put down the answer. So how much I'm expecting? .38. So this is approx 0.38. I will put down the value here. 1 plus 0.38 upon 1 minus 0.38. So I do have the answer. That should be equal to 8 is divided by 0.62. 0.89. Sorry, ये क्या कर दिया? 1.38 divided by 2. That is 2.23 approximately. Okay, 2.23. None of the option is perfectly matching. 2.23. Option number A होना चाहिए. Let me check out the calculations once. 40 plus J30 minus 50, correct? So, oh, sorry. यहीं पे शायद ये sorry. This is minus 10. This is minus 10. And then this is okay. So, this is minus 1 plus J3. Minus 1 plus J3. So, this is going to be a change. This is going to be 1 square plus 3 square. And that becomes 10. Oh, so now the calculations are also expected जो without calculator हो जाएंगे. That is 1 by 9 and 1 by 3. Under root of 1 by 9. That is 1 by 3. I will put down the value here, guys. It is simple now. 1 plus 1 by 3 upon 1 minus 1 by 3. And that is 4 by 3 by 2 by 3. Cancel. Okay, 2 आ जाएगा. Option number A. Perfect match. Chinmay, it's a perfect match. You can check it up. Option number A will come up as the answer. The final answer, option number A, is going to come up as the answer. Done? Chalte. Next question, dear. An antenna radiates a total power of 20 kilowatt and has a directive gain of 15 dB. What is the electric field at a distance of 10 kilometer away from the antenna? 10 kilometer away from the antenna. Yes, Manasvi, correct. Perfectly 2 aa jayega. Now, it has a directive gain of 15 dB. First of all, it is given in decibel. That is 10 log of directive gain. GD bolenge jaise is 15. So what is the value of GD? It is 10 raised to the power 1.5. Okay, 10 raised to the power 1.5, which is 10 power 1 into under root of 10. 10 power 3 by 2 हुआ 0.316. So ये हो जाएगा 31. Yeah, correct. 31.6. Root 10 is 3.16. 31.6 इसको लिख दिया. That is GD. Yeah, correct, Chinmay now. Now, what is the formula for GD? Right, it is given by the final formula 4 pi r square P average divided by P rad. अब इसमें से क्या क्या given है? Okay, right, electric field निकालना है. उसके लिए first I need P average. Distance is given and radiated power. All of these things are given to you. All of these parameters are given for you. Okay. Yeah, we'll do for W also quickly. Maybe next week. Chalo, done it. So we'll just put down and we'll first calculate what is the value of P average. That is GD. GD is 31.6 multiplied by radiated power. Okay, radiates a total power. This is known as the radiated power. That is 20 kilowatt. 20 into 10 power 3 divided by 4 pi into R square. What is the value of R? R is 10 kilometer. Right, so that is 10 into 10 power 3, but iska whole square. Okay, so now just try to complete the calculation. Approximately 31.6 or 3.14 isko approximately 10 se cancel karunga. Right, so approximately 10, that's what we can manage without calculator. Approximately 10, right, into 20 by 4 ho gaya 5. Right, and now we have to look into what is the 10 power left. This is cancelled, this is cancelled. 10 power 3 and this is 10 power 8 ऊपर आएगा तो 10 power minus 5. Right. So ultimately 5 into 10 power minus 4 approximately. Okay. Now this P average is given by the formula mod E square. Actually I need the mod E then. So what is the mod E square? It is P average into 2 eta. Value लिख देंगे. P average is 5 into 10 power minus 4 is multiplied by 2 eta, right? That is 2 into 377, right? That is approximately, again, how much? 5 2s are 10. Okay, so 377 into 10 power minus 3. ठीक है, 10 power minus 3. या इसको divide by 10 कर लें तो 37.7, 10 power minus 2. So mod E should be approximately how much? This is mod E square. तो 6 point something 6 के रेंज में आंसर आना चाहिए. या I have that option number B. Approximate कर देंगे. 6.1 लिख देते हैं suppose. Okay, 6.1, 10 raised to the power minus 2 volt per meter. But they are looking in the form of millivolt per meter. Right? नहीं तो into millivolt कुछ तो error हुआ है. ये 10 power minus 2 है. हाँ. After taking the under root, sorry. After the under root, it is 10 power minus 1. So this is 610 millivolt per meter. Yes, so I have a good match here. Okay, we can attempt this without calculator. Okay. Yes, Shio. Yes, Morthala. Correct answer, guys. Okay. Very correct answer. Chalo. Moving ahead to the next. Tell me the next answer, dear. Hello. Ready? ठीक है सर, बस 1 मिनट में कॉल करता हूँ आपको. Yes dear, come on. हाँ, one and the same thing you can calculate, Chinmoy. ठीक है. So for a given inductor, the value of the inductor is L, the number of turns is L, relative permeability is 1, area of cross section is A, and the length of the core is L. Okay, if the inductor is immersed in a liquid having mu r is 0.25, what is the value of the new inductance? L is given by the formula mu n square S, yeah, A will be only divided by L. So it is proportional to relative permeability. Now they've given a permeability less than 1. Okay, let's take the data, whatever they have given is usually not the desired value. Then the value of new inductance. So definitely it is proportional to mu. If earlier it was 1, the relative permeability, now it is 1/4 of it. So answer is going to be Answer is going to be L by 4. It is going to be L by 4. Okay. So some questions will be very, very direct. Some questions will be very, very direct. Okay. Now, dear. Okay. Once again, an updater that Tuesday we'll be bringing you the lug workshop. And now Ashu sir is going to join us, dear. Ashu sir is going to join us and he's going to continue. So we are done with 27 questions. Okay, there will be total 100 questions and now Ashu sir will take network control and etc. Then Sanjay sir, Saket sir, all of the expected type of questions for electronics will be covered up. Stay tuned and just within a minute or less than a minute, Ashu sir is going to join all of you guys. Just a minute. Sir, stop kar दूं मैं? Just a second.
Now tell me, now I think audio is clear. Tell me everyone, is it clear now? Okay, now it's clear. Okay guys. So from my side it's clear. I hope you are enjoying and now I will discuss some questions on control system, network theory and instrumentation. Okay. And one more question on power electronics. So these questions we are going to solve now. Okay, so thank you Rakesh sir, and I hope you guys are enjoying and I hope you got the idea about the HAL question level. Questions level are very simple. Okay, so let's come to the questions. Question number 28 is on your screen. Consider the block diagram representation of the system shown in the figure. Now we need to calculate C upon R. Tell me guys, what is the correct answer? Do it fast, everyone, please do it fast. We need to calculate C upon R. It's very easy question. It's very easy question. Do it fast, tell me the answer. Tell me the answer guys. It's very easy. It's very easy. And don't forget to like this session, everyone. Please like it, subscribe it if you have not subscribed our channel. So try to solve this question. It's very easy, very simple. What we can do is we can break this summing point. We can break this summing point and we can make it 2. We can make it 2 like this. Okay. And we can also break this. Okay. So this is 2. And now we can break this. I mean this 4 can be shown like this. Okay, this is my C and I have shown this 4 like this. It is negative feedback. Okay, I hope it is fine. Now and there is no need to show this block. There is no need to show this block. Now what you can do is from there, this point, you can also take one more feedback and that feedback is 4 into 1. So again 4. 4 into 1 is 4 again. Okay, and here you have 1, here you have 1, and this is the summing point. Okay, so you can modify this block diagram like this. Okay, it's very easy. Now you can solve this feedback loop and then whatever the answer you got, then you can use this feedback loop. Okay, so let's try to solve it. So tell me guys, what is the transfer function of this loop? It's GS divided by 1 plus GSHS 8. GS into HS is 8. So 2 by 9. So you're getting 2 by 9 here. Okay. So that 2 by 9 into 1 is again 2 by 9. So now this entire GS is 2 by 9. Okay. So the overall transfer function will be 2 by 9 GS divided by 1 plus GS into HS. 2 by 9 into 4. That is 8 by 9. Okay, so it came out to be 2 by 9 into 9 divided by 17. Okay, this is goal. So the answer is 2 by 17. Okay, 2 by 17. Now, can you tell me what is the decimal value of this 2 by 17? 2 by 17 is 0.1. Tell me guys, 0.1, and I think this is the correct answer. Bombay, 0.117. Please check it. Please check the calculation. Okay, because I don't have the calculator. I think this is the correct answer. 0.11 something. Okay, let's move on. Let's come to the next question, guys. And the next question on your screen is, we have the pole location. The damping ratio of the system is, I need to find zeta. Tell me how to calculate zeta. If you know the pole location, so pole location is, real part is -1 and the imaginary part is J2. Okay, here the pole location is, okay, -1 plus J2. You can see that. Now this length is 2, this length is 1. We know that this angle phi, cos phi is zeta. If you remember, this cos phi is zeta. Okay, now tell me what is the correct answer. Everyone reply. You are not replying, it's a bad habit. Please reply, everyone. I'm looking at your chat. Okay, looking at your messages. You are not replying. Tell me what is the correct answer. So you know the pole location, you need to calculate the zeta. How to calculate the zeta? You need to find cos phi. Cos phi is equal to base upon hypotenuse. Base is 1, hypotenuse is root phi. Okay, so 1 upon root phi. 1 upon root phi, you can calculate this value. Root phi is 2 point something. Okay, so it is less than 0.5. I think answer is Agra. Answer is Agra. Okay, okay, so answer is Agra. Let's move to the next question, guys. Now next question on your screen is this: the second order system described by the differential equation. So we have the differential equation. Okay, theta I and theta naught are the input and output shaft angle respectively. The natural frequency of the system is, we want to know omega n. So what you can do is, you can calculate the transfer function from here. So let's calculate the transfer function. If I calculate the transfer function, then it will be theta naught s upon theta I s. How to calculate this? By taking Laplace. On both sides you can take Laplace and you can calculate. So it will be k divided by js square plus fs plus k. Okay, now what you can do is, you can take this j common, so it will become k by j divided by s square plus f by js plus k by j. Okay, so this is my transfer function, guys. And we know that if you compare it with the standard second order system, this represent omega n square. So omega n is root of k by j. Okay, root of k by j. Answer is Agra. So this was again very simple question. You can solve it easily. Okay, let's move to the next question, guys. The next question on your screen is, we have open loop transfer function with unity feedback system. Okay, so GSHS is provided to us. Okay, GSHS, you can write it like this because HS is 1. So GS is also equal to GSHS, and you can write it like this: k divided by s into, you can take s common, s into s square plus 4s plus 5. Okay, so this is my GSHS. Now we need to find the value of k at one of the breakaway or break-in point, the root locus of the system. We need to find what is the value of k at the breakaway point. How to calculate the value of k at the breakaway point? Tell me, guys, how to calculate the value of k at the breakaway point? First of all, you need to calculate the breakaway. What is the breakaway point? For that, what you need to do is, you need to find, we know that GSS is equal to -1. Okay, so what you can do is, you can calculate k from here. K will be equal to minus of s into s square plus 4s plus 5, or you can multiply. It will be s cube plus 4s square plus 5s. This is the value of k. Now from here, you can calculate dk by ds. And dk by ds will be equal to minus of 3s square plus 8s plus 5. Okay, this is my dk by ds, and you can put it equal to 0. Okay, so you can calculate the value of s at which this function becomes 0. Now let me get the calculator. Okay, let me get the calculator to calculate this value. So 3 equal to 8 equal to 5. Okay, now you get s is equal to 1 s equal to -1, and the other one is -5/3, -1.67. These are the values of s. Now the question is, at what point you need to take the breakaway point? Let's see. So for that, what you can do is you can draw its root locus. So we know that one pole is lying here. What about the other poles? What are the poles of this system? So what you can do is, again you can solve for this equation. Okay, so let me calculate the roots of this equation. It is 1 equal to 4 equal to 5. Okay, and if you see, one root is at -2 plus j and -2 minus a. These are the other two roots. Now if you look at the part of the real axis which will be on the root locus, this will be the part of root locus. This will also be the part of root locus. Okay, this is the part of root locus, this is also the part of root locus. So on the real axis there are 2 points. One is at -1, this is -1 point, and one is at -1.67. This is at -1.67, -1.67. Okay, so you can see that there are 2 points on the root locus. These 2 points will lie on the root locus. So at this point, let's calculate the k value. At this point also, let's calculate the k value. How to calculate the k value? We know the s value. If you know the s value, you can put it here and calculate the k value. Let's put s equal to -1 first. If I put s equal to -1 first, then k will be equal to, you can calculate k from here. If you put s equal to -1, it will become -1 into -1, that is become +1. Okay, 1 minus 4 plus 5. Okay, so it will become 2. So k is 2. So at this point it will be equal to 2, but 2 is not in the option. 2 is not in the option. Now what is this point? This point is -5/3. We know that. So let's put s equal to -5/3 and let's calculate the k value. So the second k value is, if you put -5/3, this will come here and it will become +5/3 into, it will become 25/9 minus 20/3. Okay, s is -5/3, so it will become -20/3 plus 5, and you can calculate this value. Okay, let me calculate this for you so that you get the k value. Okay, so it is 5/3 into 25/9 minus 20/3 plus 5. Okay, so you can calculate this k value and it came out to be 1.85. Okay, so answer is 1.852. Answer is Delhi. Okay, this was a simple question. We need to find the value of k either at the breakaway or break-in. So we have 2 points. Obviously one will be breakaway and one will be break-in. Okay, one will be breakaway and one will be break-in. Now first we have calculated the breakaway or break-in point. How I have done? I have calculated GSS equal to -1, then I calculated this k value and then applied dk by ds equal to 0. From there I got these 2 points. So out of these 2 points, one is breakaway, one is break-in. Okay, so at this point we have calculated the value of k. At this point we have calculated the value of k. At this point what I did is I put this s equal to -1 here and calculate the k value. The second point is this, I put the s value as -1.67 and calculated the k value. In the first case the k came out to be 2, and in the second case k came out to be 1.852. So 2 is not in the options. That's why 1.852 is the correct answer. Let's move to the next question. Which of the following statement is true for type 2 system having unity negative feedback? Okay, so system is type 2. System is type 2. Now if you remember, in type 2 acceleration error constant can be calculated. That is equal to limit s tends to 0 s square gs. This is my Ka, and the steady state error is 1 over Ka. So it will be finite. Acceleration error constant will be finite. Okay, Ka will be finite and the steady state error due to acceleration error constant will be finite. So 2 is the correct answer, that's for sure. Acceleration error constant K is equal to this is wrong. It will not be infinite, it will be finite. Okay, acceleration error constant will be, position error constant will be equal to 0. Let's calculate the position error constant. We know that the position error constant Kp is equal to limit s tends to 0 of GSHS. Okay, HS is 1. So if you put s tends to 0 in this function, it's a type 2 function, so it will become infinite. Okay, so Kp will be infinite. Okay, the position error constant Kp is 0. No, this is not correct. Now let's come to the third. Steady state error due to unit step displacement input is equal to 1. Now if Kp is infinite, what is the steady state error due to unit step? Due to unit step, the steady state error is 1 over 1 plus Kp, and since Kp is infinite, the steady state error came out to be 0. So due to unit step disturbance, the steady state error has to be 0. Okay, so this is also not correct. So answer is none of these. No statement is correct. Okay, so I hope it is clear, everyone. Let's come to the next question. Next question on your screen is this. You can see that the asymptotic Bode magnitude plot of open loop transfer function of a unity negative feedback system is shown in the figure. Okay, this is the parabolic input. So for parabolic input, we need to calculate the steady state error. Now how to calculate steady state error for parabolic input? We need to calculate acceleration error constant Ka. Now what is Ka? Ka is equal to limit s tends to 0 of s square gs. Okay, this is my Ka value. Now how to calculate Ka from Bode plot? Bode plot is given. How to calculate the Ka value? We know that in the Bode plot, this is the function. Now in this function, the first line, look at the first line. Whatever this first line is and whatever its height at omega equal to 1, that height at omega equal to 1 will be 20 log Ka. If you remember from Bode plot, whatever the first line is, it's a type 2 system, you can see that. In type 2 system, K will be finite. Okay, in type 2 system, look at the first line, whatever the first line is, we need to check the height of the first line at omega equal to 1. Now it is given that this point is at omega equal to 0.1. At omega equal to 0.1, it's 0 dB. Now what will be at omega equal to 1? At omega equal to 1, it will be minus 40 dB. It will be minus 40 dB. How can you say that? Because the slope is minus 40 dB per decade. And if you are moving from 0.1 to 1, it means you are going 1 decade away. Okay. So in 1 decade, 40 dB will be down. So at 0.1, it's 0 dB. So at 1, it's 1 decade away. It will be minus 40 dB. So this height will be minus 40. Okay. Now K will be equal to 1 by 100. K will be equal to 1 by 100. You can easily calculate that. Okay. Once you get this Ka, you can put it here. Okay. So the steady state error will be 1 upon 1 by 100. 1 by 100 is, what is this value? It will be 100, but 100 is not in the option. So let me see it again. I think this point is not clear, whether this point is the origin point or maybe this point. Okay. Omega is 0.1. I don't know omega 0.1 is this point or this point. Let's take omega equal to 0.1 at origin. I mean this origin point, this crossing point is 0.1. If the crossing point is 0.1, then at omega equal to 1, what is the height? It will be minus 20 dB, because omega equal to 0.1, it's 20 dB. So at omega equal to 1, it will be minus 20 dB. Okay, it is minus 20 dB. So if I write it minus 20 here, then you will get Ka will be equal to 1 by 10. Ka will be equal to 1 by 10. And if you write 1 upon Ka, it will become 10. Okay, it will become 10. So the answer is Agra. So I think this 0.1 is this frequency, because using this frequency you can calculate the steady state error and option will be matched. Okay, so we are not sure whether this 0.1 is this frequency or this frequency. So if I take this frequency as 0.1, then you can get the answer. Okay, so it's easy, guys. This is 0.1. At 0.1 it's 20 dB. So at 1 it will be minus 20 dB. Using this slope, you can say that if you are moving 1 decade away, this height will go down 40 dB. So if it is at plus 20, it will be at minus 20 at this point. So omega equal to 1, you will get minus 20. Okay, so this is minus 20. You can calculate the K value as 1 by 10, and 1 upon K is 10 then. Okay, so the steady state error is 10. Now let's come to the next question. Next question is on your screen. Which one of the following diagram correspond to a lag network? So we need to see which represent the lag network. Okay, lag network. Now, first of all, we need to understand what is lag network and how to draw a lag network. So, lag network means if it has a negative phase. Let's say the transfer function of the lag network is like this. Let's say this is S plus, maybe if I write down the transfer function, it will be S by, let's say, alpha plus 1 divided by S by K alpha plus 1. Let's say this is my GSHS. Okay, this is my GSHS. Or maybe GS only. This is the transfer function of the lag network, or you can say compensator, lag compensator. This is the transfer function. Now, what is the condition on K? If you calculate its angle, it will be tan inverse of omega by alpha minus tan inverse of omega by K alpha. Now, to make this network lag, K has to be less than 1. K has to be less than 1. It means if it is alpha, let's say if it is 2, then it should be less than 2. Okay, because K is less than 1. Then only, if K is less than 1, then only this angle came out to be negative, and we call it lag network. Okay, so this is the condition for lag network. But the question is, we want to find, this is the current, this is the resistance. It means I need to draw a network, lag network I need to draw. Okay, this is for the compensator, but we need to draw lag network. Now, how to draw lag network? Okay, let's see. I take a resistor and a capacitor. Let's see whether it is a lag network or a lead network. So what I can do is I can say that this is VIS, this is V0S, and this is R, this is 1 by CS. Okay. Now you should remember the lag network, then only you can solve it. Otherwise, it's not able to. Like I don't remember the lag network. I don't remember. That's why I'm trying to find a lag network. Okay. Let's see. Let's say that this is the lag network, and I have to check whether it is lag network or not. So first let's calculate the current. The current is VIS divided by R plus 1 by CS. Okay, R plus 1 by CS is the current, into 1 by CS is my V0S. Now, if you solve this clearly, it will not represent a lag network. It will not represent a lag network. Okay, because it will not be like this. So what I need to do is I need to modify it. Okay, let's go with the lag network. Now tell me, can you tell me what is the diagram of the lag network, guys? Because otherwise you will not be able to solve it. Let's take it like this. If I take it like this, again this is the current, and whatever the current is, multiply by the resistance. Okay, this is my V0S. Now if you calculate V0 upon VIS, then it will be V0S upon VIS. If you calculate this, it will be equal to, RCS divided by RCS plus 1. Okay. Now again, it is not a lag network, it is a lead network. It is a lead network. Now what I can do is I can further modify it. Okay. Let's do one small modification. So I'm not getting lag network. First of all, I need to get the lag network. Okay. So what I'm doing is I'm doing it like this. I take a resistance here, take a resistance and a capacitance. Okay. Let's take it R1, R2, and this is C. In Laplace domain, it will become 1 by CS. Okay. Now if I calculate this, if I calculate the current, it will be VIS divided by R1 plus R2 plus 1 by CS. This is the current. Once you get this current, multiply by the impedance of this path, and the impedance of this path is R2 plus 1 by CS. Okay, this is the impedance of this path. This is equal to V0S. Now if I simplify, I will get V0S over VIS. That will be equal to, you can say that R2 CS plus 1 divided by R2 CS plus 1 divided by, it will become R1 plus R2 into CS plus 1. Okay. Now what I can do is I can simplify this. So you can see that it will become S divided by 1 by R to C plus 1. This will become alpha. Okay, divide by S divided by 1 divided by R1 plus R2 into C plus 1. Okay, so if this is alpha, this will become K alpha, and we know that this is less than this value. This value is less than this value. Okay, this value is less than this value, because you can see that. So now this represents a lag network. Now this represents a lag network. Okay, is it clear? I hope it is clear, guys. Okay, I hope it is clear how to calculate this. So this is a lag network. So we got the lag network. Now if you change the frequency, if you change omega, what will be the current versus impedance? We need to check the current versus impedance. If you are moving this omega, how the impedance is changing, okay, and how the current is changing, we need to check that. So what is the current expression? So current expression is this voltage divided by this impedance. This is the current expression. Okay, we don't need the transfer function. Transfer function was just to check whether it is a lag network or lead network. Okay, once you get it, let me erase this. Okay, it's not required anymore. Okay, now we got this lag network. So we have this lag network. Now let's check, if you change the omega, how the current will change. Okay, and you can give the values also, no? You can give the values to this R1, R2 and C. Let's take R1 as 1 ohm, R2 as 2 ohm, and C as maybe 1/2 farad. Okay, now let's take, this is the network we have. Now what is the current? Current will be VI divided by total impedance. Total impedance is R plus J omega L. So R is 3 plus J omega C plus minus J by omega C. Okay, because capacitive reactance is there. No? So minus J by omega C. So 2 by omega. Okay, so this is the current in this circuit. This is the current which will flow in the circuit. Now this will become VI divided by root of 9 plus 4 by omega square. This is the magnitude, and the angle will be, you can see that it is in the fourth quadrant. So angle is 10 inverse of imaginary part by real part. So 2 divided by 3 omega. This is the angle. Tell me, guys. I hope it is clear. In the denominator, the phase is negative, but if it come into numerator, it will become positive. You can see that. Okay. So this is the phase, and this is the magnitude of the current. Now, if you see carefully, at omega equal to 0, we have some magnitude of the current, and the angle is at minus. If omega is 0, angle is at 90 degree. Angle is at 90 degree. When omega is 0. When omega is 0, you can see that when omega is 0, the impedance is purely imaginary. Impedance is not real. So let me check. Wait a minute. I think this is not the current. This is the imaginary axis. Excuse me for that. This is the imaginary axis. This is the real axis. Okay. So that is how it is done. Excuse me, guys. Okay. So there was a confusion from my side. Anyway, so we got that this is the imaginary axis and this is the real axis, and I am varying omega. If you are varying omega, then obviously your impedance will vary, and your current will vary, your voltage will vary. Everything is variable. Okay, you can see that everything is varying. Now let's first look at the impedance. What is the impedance? If you look at the impedance, it will be 3 minus J by omega C. Okay, so this is the impedance we have. Because if you calculate the impedance, it will be total resistance, that is 3 minus J by minus 2J by omega. Okay, this is the impedance. Now if I calculate the magnitude of this impedance, the magnitude of this impedance will be a root of 9 plus, it will become 4 by omega square, and angle is minus 10 inverse of 2 by 3 omega. Okay, this is the magnitude and this is the angle. Okay, So we found the impedance. We found the impedance. Now the question is, once you get this impedance, you can plot it. If omega varies, you can plot it. But the problem here is, I don't know what is this graph. I mean, the real part and the imaginary part is for what? Current or voltage? Is it for output voltage or is it for current? It's not mentioned in this question. We know that this is the lag network. Now for the lag network, this is the impedance. So the polar diagram can be of impedance also. It can be of current also. It can be of voltage also. It is not mentioned which polar plot is this. Is it for impedance or is it for current or is it for voltage, output voltage? We don't know that. If you don't know that, you will not be able to check that. Because if you look at the impedance, you can see that if omega varies, this impedance also varies. This is the magnitude, this is the angle, and you can draw the polar plot. No problem at all. Okay, I hope you got my point. Okay, so this is the issue with this question. This is the issue with this question. Now, let's think about transfer function, because many students are thinking that, sir, why don't you go with the transfer function? Okay, so let's go with the transfer function. If I look at the transfer function of this system, then the transfer function will look like this. And if you plot the polar plot of the transfer function, let's check with that. Okay, so what is the transfer function of this? Transfer function is VIS divided by 3 plus 1 by CS, so it will become 2 by S. This is the current into this impedance, 2 plus 2 by S. Okay, this is my V naught S. Now you can calculate V naught S over VIS. So V naught S over VIS is, you can simplify this, it will become 2S plus 2 divided by 3S plus 2. Is it clear? Now you can simplify this, it will become S plus 1 divided by 1.5 S plus 1. Okay, so this is my transfer function. Now, what is the angle and magnitude of this? If I replace this S with j omega, the magnitude will become omega square plus 1 divided by 1.5 omega square plus 1. Okay, 1.5 omega square plus 1. This is the magnitude, and the angle is tan inverse of, you can see that 1.5 omega, this is minus, plus tan inverse of omega. Okay, so this is the angle and this is the magnitude. Now let's start with the magnitude. When omega is 0, you can see that this magnitude is 1 and angle is 0. So it will start from the real axis. It has the magnitude 1 when omega is 0. So now you can see that this is also at the real axis when omega is 0. This is also at real axis when omega is 0. This is also at real axis when omega is 0. And this is also at real axis when omega is 0. Now if you increase omega, this angle will go negative. It means this cannot be the correct answer. This cannot be the correct answer. Why? Because the angle is moving in positive. Okay, this is also in positive in the first quadrant. So either this is correct or this is correct. Now let's see whether it is correct. This is correct or this is correct. Now how to check? When omega tends to infinity, this angle again goes to 0. This angle again goes to 0. What about the magnitude when omega goes to infinity? When omega goes to infinity, you can see that the magnitude will become 1 upon 1.5. This is the magnitude. When omega tends to infinity, you can check it. You can take omega square common from denominator and numerator. Okay? And you put omega tends to infinity. Then you will get 1 upon 1.5. It means the magnitude is less than 1. When omega was 0, the magnitude was 1. Now it is less than 1. It means it is more closer to origin at omega equal to infinity. Now you can see that at omega equal to infinity, it is more closer to omega equal to 0. That's why the answer is this. Okay. So simple way you can solve like this. But this question was very tricky, and this is the only question which was tricky. Okay. So you should know what is the lag network, and then with the help of lag network, you need to draw its transfer function. If you know the transfer function, you can check its polar plot. Easy peasy. Okay. Let's move to the next question, guys. The next question is, we need to calculate the equivalent capacitance. How to calculate? What is the equivalent capacitance? It's again very simple question. Let's try to solve this question, guys. You can see that these two capacitors are in series, so their equivalent will be 0.5, okay, their equivalent will be 0.5, 0.5 in parallel with 1, so it will become 1.5, okay, 1.5. Now let me draw it. So we have this 2 farad, 2 microfarad, and we have 1.5 microfarad, okay, again we have 2 microfarad, okay, and we have this 2 microfarad, okay. So this is the circuit. Now let me repeat this. I have combined it, they are in series, so it will become 0.5, 0.5 in parallel with 1, it will become 1.5, okay. Now you have this circuit, and in this circuit 2 and 1.5 in series. So what is the equivalent capacitance? 2 into 1.5 divided by 3.5. So it will become 3 divided by 3.5, okay. This is the equivalent of these capacitance, 3 divided by 3.5. It means 30 upon 35. You can cancel it with 5. 6 by 7. So 6 by 7 is the series equivalent. Now 6 by 7 plus 2, because it is in parallel. So 6 by 7 plus 2 is, it will become 20 by 7, okay. 20 by 7, almost 3. You can write it like this, almost 3. And this equivalent 20 by 7 is in parallel with 2. So let's take this in series with 2. So if this 2 microfarad is in series with this 20 by 7, then the equivalent will be 20 by 7 into 2 divided by 20 by 7 plus 2, okay. So it will become 40 by 7 into 7 divided by 14 plus 20. 14 plus 20 is 34, okay. So 40 by 34, you will get 40 by 34, okay. Now I think this is the correct answer. Agra is the correct answer, okay. This was again a simple question, you can solve it easily, okay, and you have to calculate equivalent capacitance, easy peasy. Let's move to the next question. What is the average value of the current wave shape? Tell me the average value. It's very simple. It's very simple. You can see that the current is changing from 5 to 10 and then, okay. Now it's a triangular wave and it's symmetric wave. So the average value is in between. It means 7.5. There is no need to do any calculation, okay. In triangular wave, when there is a symmetric triangular wave, okay, you can see that during this length it's moving upward and moving down the same, okay, and it has the same positive and negative slope. So it's a symmetric wave. So the average value means DC component is 7.5. Answer is Calcutta, okay. So this was very easy question. Let's move to the next question, guys. Next question on your screen is, consider the circuit shown in the figure below. We have this circuit, the value of the source current I, we need to calculate this value of I. Now you can see that this is not a balanced bridge. So what you can do is, you can apply star delta conversion. So if I apply star delta conversion, then you will see that here you can convert this into star, okay. So let's convert this into star. This delta you can convert into star, okay. Now this 5 into 5 divided by 5 plus 5 plus 5, so it will become 5 by 3. This is also 5 by 3, this is also 5 by 3, okay. 2 and 3, this is 3 and this is 2, okay. So this is the circuit we have. This is the circuit we have, and we need to find this current I. So first I need to calculate the equivalent resistance. So how to calculate equivalent resistance? You can combine them, okay. So let's see what is the equivalent resistance. It's 5 by 3, and if you combine it, this resistance will become 5 by 3 plus 2, 11 by 2, okay, 11 by 2, and this side the resistance will become 5 by 3 plus 3, okay, 14 by 3. This is the equivalent. Now you can see that it is 4 point something, and this is 5 point something, okay, 5.5 you can say. This is 5.5 and this is 4.67. Fine. Now I need to take their parallel, and this value is almost 1.67. This is 1.67. I am telling you the rough idea, okay. So almost this is 5 or this is 5. So if you take the parallel, you will get almost 2.5, roughly 2.5, because this is almost 5, this is almost 5, okay. So if you take 5 parallel, you will get near about 2.5. It's a rough idea. This is 2.5, this is almost 1.5. 2.5 and 1.5. if you add it, you'll get 4. It means almost equivalent resistance is near about 4. I'm not calculating it, almost near about 4. And this voltage is 3. So 3 by 4 is nearly equal to 0.75. Actually, this resistance should be, I think, more than more than 4. I think it should be more than 4. Okay. So it should be less than 7.75. So you can see that this cannot be the correct answer. This cannot be the correct answer. Only two options are, one is less than 0.75, one is greater than 0.75. So we have to select out of these two. You can even calculate. Let's do the calculation. 14 by 3 in parallel with 11 by 2. So what you can do is 14 by 3 into 11 by 2 divide by 14 by 3 plus 11 by 2. So it will become 14 into 11 divided by 6 into 6 divided by 28 plus 33. Okay. Now this is gone. Now it will become 14 into 11 divided by this total resistance. What is this resistance? This is 1 here and 61. Okay. So you can see that this is, so 14 into 11 by 61. This is the equivalent resistance of these two. Now if I calculate this 14 into 11 by 61, it came out to be 2.52. This is almost 2.52. Okay. 2.52 plus 1.67. Okay. So this came out to be 4.19. So equivalent resistance is almost 4.19 and the voltage is 3. So 3 divided by 4.19 and the answer is 0.715. 0.715. No option is given here. Okay. No option is given here. Okay. I think options are wrong. No option. So 0.715, it's nearly 0.80. It's almost 0.80. I'm near about this. We have to put this current. Otherwise, there is no other choice. Okay. So let me check whether I have done all calculation correctly or not. So 5 by 3, 5 by 3, 5 by 3 plus 3. So I think this is correct. 14 by 3 and this is 11 by 2. That's correct. 14 by 3 and 11 by 2 in parallel. So 14 by 3 into 11 by 2 divided by 14 by 3 plus 11 by 2. So it will become 14 into 11 by 6. And here 6 will go in the number 28 plus 33. That's correct. This is gone. So 14 into 11 divided by this sum. What is this sum? I think this is correct. 61. So correct answer is 0.71. Okay. 0.71 is the correct answer. So that's why I'm putting 0.80. It's nearly 0.71. That's why. Let's come to the next question, guys. The next question on your screen is this. Okay. And the next, in the circuit, IT has Laplace transform this. This is now the final value of IT. What is the final value of IT? You can apply the final value theorem here. Okay. Let's apply the final value theorem. Multiply it with S. This S will be gone and put limit S tends to 0. So it will become 3 into 10 divided by 12. If I multiply it with S and put limit S tends to 0, you'll get the final value. Okay. So this is gone and 2.5. So answer is 2.5. This is the correct answer. Okay. Let's move to the next question. The next question on your screen is this. You can see that, consider the following figure. Okay. So we have this figure. The steady state is reached when S is open. Okay. Previously the S was open. If S is open, there was no voltage across this capacitor and the entire current was flowing through this. This inductor current was 2 ampere. Now, if S is closed at t equal to 0, at t equal to 0, you have closed this switch. The voltage VL across the inductor at t equal to 0 plus. At t equal to 0 plus, what is the voltage across the inductor? So, if you close this switch, what will happen? This capacitor will try to maintain its voltage. And what was the voltage across the capacitor? It's 0 volt. Now, if you close this switch, it will try to maintain its voltage. It means across this branch, it will have 0 volt. Now, if the total voltage across this branch is 0, and we know that this inductor will try to maintain the current. So, there will be an initial voltage across this this resistor, that is 4 volt. 2 into 2, that is 4 volt. And let's assume that this is grounded. Let's assume that the lower point is at 0 volt. Now, the upper point should also be at 0 volt. Why? Because the voltage across the inductor capacitor is 0. If lower is 0, upper should also be 0. Okay. So, if this is 0 and if you go down, this will become -4. So, this point is -4, this point is 0. What is now voltage across inductor, this voltage, this minus this. What is this voltage? Upper point voltage minus lower point voltage, you will get -4 answer. Okay, so voltage across the inductor is -4 now. Answer is Delhi. Okay, answer is Delhi. This was again very simple question. Let's come to the next question. Now a current wave shape is provided to us. Okay, and this current is flowing through 30 ohm resistor. 30 ohm resistor. It is flowing through 30 ohm resistor. The average power dissipated. So how to calculate the average power dissipated? Whenever the power dissipation is required, we use RMS value. Okay, we use RMS value. So what is the RMS value of this current? Let's calculate. So the equation for this is 10T and the period is 1. So RMS value is 10T square dt, 0 to 1, and period is also 1. This is the RMS value. IRMS square into 30. So I have to take the square of that into 30. Now what is this value? First of all, let's calculate this value. So 100 into t square, and why I have to take integration of t square. T square integration, it's t cube by 3 and limit 0 to 1. Okay, so this is the RMS value, guys. So RMS value came out to be 100 by 3 root. This is RMS value. Now I have to take the square of this RMS value. So square of this RMS value is 100 by 3 IRMS square into R. R is 30. This is gone. So you'll get 1000. Okay. So 1000 watt is the correct answer. Answer is Bombay. Let's move to the next question, guys. The next question on your screen is this. In a series RL circuit, so we have series RL circuit. Okay. In a series RL circuit, the inductance is 20 millihenry. This is 20 millihenry, and the magnitude of the total impedance is 17.85. This is the magnitude. Okay. If the angle of the lag of the input current from the applied voltage is, okay, this current lags the voltage by some angle theta, which is 63.5. The angle lag is given to us. Then the value of omega. I need to calculate the value of omega. So how to calculate the value of omega? It's very easy. We know that the angle by which this current is lagging from this voltage is equal to the impedance angle. And the impedance angle is 10 inverse of omega L by R. Omega into 20 into 10 raised to power minus 3 by R. Okay, and this is equal to 63.5. Okay, so we got this. And the next is magnitude. Magnitude is R square plus omega L square. This is equal to 17.85 square. Okay, and better you write it omega L here. Better you write it omega L here. Okay. Now what you can do is from there you can take this 10 inverse on this side and omega L by R you can calculate. Omega L by R is equal to 10 of 63.5. Now what is this 10 of 63.5? Tell me, guys. So 10 of 63.5 is 2. So from here R will be equal to omega L by 2. You can put it like this. R is equal to omega L by 2. So if I put R here, it will become omega L square by 4. Okay, this will become omega L square by 4 plus omega L square, and this will become 17.58 square. Okay, so it will become 5 by 4 omega L square, and that is equal to 17.58 square. Is it clear, everyone? Now from there you can calculate omega L. Okay, so it will become 17.58 square multiply by 4 by 5. Okay, I have taken this 4 by 5 on this side. Okay, and then take the root. So you'll get omega L. Omega L is 15.72. Omega L is 15.72. Now if you got this omega L, you can calculate omega from here. Take this L in the denominator, and L is 20 millihenry. So you can divide it with 20 millihenry. Okay, you can divide it with 20 millihenry, and the answer you get 786, almost 786. It means this is the correct answer. Actually, it is not exactly true because the answer is 786. So near about answer is this. Okay, I hope you got the point how to solve this problem. This was again an easy problem. Let's come to the next question. Next question on your screen is, we need to calculate the current value in this diagram. What is the current value in this diagram? So again, it's very easy. So tell me guys, you can see that this current I need to calculate. Now how to calculate this current? You can replace this branch with the voltage source. Similarly on this side you can replace it with voltage source. So the circuit will look like this, 28, okay. Here on this side, if you replace it with the voltage source, it will become 4 ohm and a voltage source in series. So it will become 40 volt. Fine. On this side, you have 8 ohm in series with the voltage source, and voltage source will become 40 volt again. Okay. You can see that. Now we need to calculate this current. So what is the total loop voltage? It's a single loop. You can see that. So the total loop voltage is 80 volt. 40 plus 40 is 80. Divide by the total resistance. Total resistance is 28 plus 8 plus 4. So it will become 40. So answer is 2 ampere. Okay. So answer is 2 ampere. Answer is Bombay. So this was again a simple question. Let's come to the next question, guys. Now network theory is completed. We have to start with the instrumentation. Okay. So this is the first one. Now instrumentation is purely memory based question. Okay. So let's come with the first question of instrumentation. Which of the following statement is true? Both refrigerator and thermocouples can be made using the Peltier effect. Okay. Now you have to remember it. Okay. Study about Peltier effect and Seebeck effect. There are similar things. Okay. Temperature and then temperature to current. Okay. So this type of effect is this. Please read it. Now which option is correct? First of all, a refrigerator can be made using the Peltier effect and thermocouples can be, so you have to remember it, and this is the correct answer. So it's a memory based question. Answer is Calcutta. Okay. So please remember it. Let's come to the next. Dead time of an instrument refers to. What is dead time? It's a very logical question. What is dead time? It means there is a system in which you have provide input and you get the output. But the dead time means that time which this system takes to get the output. It means you have provided the input, but still output is not there. It will take some time to process that. Okay. So that is known as dead time. Okay. So dead time means the time before the instrument begins to respond after the quantity has altered. It means the input quantity has altered. Okay. After how much time it will give the response. That is known as dead time. Okay. Wait a minute. Retardation or delay in the opposite of an instrument. To a change in the input signal. That is also confusing. Wait a minute. Retardation or delay in the opposite of an instrument to a change in the input signal. No. Delay in the opposite of an instrument. Opposite of instrument, I don't know what is opposite of instrument. Okay. That's correct. If you change the input signal, by how much delay time you are getting the response. Okay. That is known as dead time. But I think this suits more. The time before the instrument begin to respond after the quantity has altered. Okay. I think this is more accurate. Okay. Because it's a bit confusing in the statement. Let's come to the next. What is done to reduce the effect of fringing in the capacitive type instrument? Tell me guys, what can be done to reduce the fringing? Again, it's a memory based question. You should remember that. Okay, you should remember that. Tell me, and it's a basic question. So if you want to reduce the fringing effect in the capacitor, we use guard rings. Always remember. Okay, and the ring should be at zero potential. Okay. We provide the guard ring and that ring should be at zero potential. Just remember it. Okay. Now tell me, what is an active transducer? Tell me everyone, what is an active transducer? Very easy. Which doesn't have external power source. Okay. And that is piezoelectric crystal. In the piezoelectric crystal, you don't have external power. Okay. So that is known as active transducer. Let's come to the which of the following instrument is useful while measuring the optical power as a function of wavelength? Optical spectrum analyzer. Okay. Optical spectrum analyzer is the instrument which can be used for measuring the optical power as a function of wavelength. Let's come to the next. Linear displacement digital transducer uses gray code. Okay. Just remember it. It uses gray code. Okay. Remember this, it's a memory based question. Now this is a numerical question. Okay, let's see what is this numerical. A moving coil instrument has a coil resistance of 10 ohm. Okay, so we have a moving coil instrument, it has a coil resistance of 10 ohm, and when the current is 100 milliampere, it gives the full deflection. Okay, it gives the full deflection. It means, what is this voltage? This voltage came out to be 1 volt. It means across this 10 ohm, if 1 volt is there, it will give full deflection. Now we want to modify and we want to use it to measure the voltage, and we want to measure the voltage from 0 to 500 volt. It means at 500 volt it should give the peak reading. Okay, it should give the maximum deflection at 500 volt. Now if you have 500 volt here and you want that this instrument which has 10 ohm internal resistance, you want that this should give full deflection at 500 volt, then this current has to be 100 milliampere, we know that, and this voltage has to be 1 volt, we know that. Now how to get this 1 volt? Obviously I need to introduce some resistance in series. Some resistance I need to introduce in series. Now what is this resistance? That you can calculate. This is 500. So 500 divided by this resistance plus this 10 ohm, R plus 10, that has to be equal to this current 100 milliampere, because you want that the full scale deflection should be there, full deflection should be there at 500 volt. It means this current has to be 100 milliampere, then only it will give full deflection. So you cannot directly apply this 500 volt, because if you apply directly 500 volt, the current will be 50 ampere, it will burn this device. I have to connect series resistance. What is this resistance value? That you can calculate from here. So R plus 10 will be equal to, now we take this 100 in the denominator, so it will become 5000. Now R will be equal to, you can calculate 4.99 kilo ohm. This is the correct answer in series with the instrument. Okay, so the answer is Calcutta. This was again a simple question. Now tell me LVDT. What is LVDT? Tell me guys, what is LVDT? So let me check. Okay, yeah. Let me call to Rathi sir so that I can ask him whether he is ready or not. Okay, let me call Rathi sir. Till then you can tell me the answer, guys. Tell me the answer, everyone. Okay guys, so now look at the question. The question on your screen is, tell me the correct answer. LVDT is a transducer. It's an inductive transducer. LVDT is an inductive transducer. Remember this. Okay, just give me 1 minute. Okay, it's an inductive transducer. Simple. Let's come to the next. Temperature transducer make use of change in resistivity. Okay, because resistivity depend on the temperature. So the temperature transducer use this property, change in resistivity. Okay, let's come to the next question. The next question is, which of the following instrument is not preferred to use high frequency range of the measurement of current? Okay, so high frequency measurement of the current, which instrument cannot be used? That is bolometer. Okay, so bolometer cannot be used for high frequency measurement of the current. Just remember it. Okay, these are memory based questions. Let's come to the next question. This is the last question I have. Okay, this is the last question I have, and the question is, the following is generally true. RC snubber is used to protect SCR. So we have SCR and we protect SCR by applying snubber circuit. So one is RC circuit. Now what this RC circuit does? RC circuit protect the device from over voltages. Okay, so it protect the SCR against device over current, no. Against di by dt, no. Against device over voltage, yes, that's correct. Over voltages, it will protect because the capacitor is there, na? So it will protect the device from going the voltage beyond some point. Okay, so it will protect the device from over voltage. Okay, so from now onwards Rathi sir will continue. So there will be a glitch of maybe 10-20 second guys, and let me call Rathi sir so that he can be on line, and then I can stop and Rathi sir will continue from there. Okay, so just give me 1 minute guys.
Hello everyone. Let me know that sound quality, picture quality, everything is fine. Now this is Sanjay Rathi. I am going to start the session with what EDC, analog and what microwave. And I will discuss very important questions from this. So if everything is fine, then please like the session, share the link of this session and subscribe our channel guys. Okay, let me know that. Okay, I will check. Okay then. Now, HAL 2023 EAC mock test, and first of all we will solve some questions from EDC, right? Now, that is the first question. The depletion region formed in the PN junction source. Tell me what is the answer for this question. When we are having the depletion region, so because of that depletion region, what is the reason, right? First of all, source. Presence of electric field due to diffusion of the carrier. Second, presence of the diffusion current. Third, separation of the PN region. And the fourth one is all of the above. So what is the answer for this question? Yes, please. Tell me what is the answer for this question. Okay then. Mansi, you are giving the answer. What is the answer for this one? Now, PN junction means what? Watch this. This is the PN junction. Here we are having acceptor impurity, and here we are having donor impurity. Concentration of electron is very high, concentration of hole is very high. Initially the hole will diffuse from higher concentration to lower, and electron will diffuse from higher concentration to lower, and there may be the what diffusion current, but in open circuit bar the current should be 0. Then what will happen? The depletion layer increases. This hole will recombine with this electron, this hole will recombine with this electron, therefore that depletion layer will increase. Once the depletion layer will increase, electric field, there is a development of the electric field, and because of these electric field there will be drift current. So drift plus diffusion, total current will become 0, and this area is called what? Depletion area, where only immobile charge carrier exists. Because of this recombination, in this area we are having only immobile charge carriers, negative ions, and here we are having the positive ions, and this is a junction here, and this is a called high field region. This is plus charge, this is minus charge, and that is the direction of the electric field from positive to negative, and this is the P region, and that is N region. So now guys, the depletion region formed in the PN junction source. Presence of electric field due to diffusion of the carrier, yes. Once the electron or holes will diffuse, therefore to oppose that electric field will develop. Second, presence of the diffusion current, yes, there is a diffusion current. Then separation of the PN region, yes, because of this there is a separation. Here we are having the immobile charge carriers, here we are having the immobile charge carriers, depletion region increases, space charge width increases, and finally what is this? All of the above. The answer for this question is what? D. Answer for this question is D. Then next one, next question. Okay, what is the answer for this one, everyone? Give me the answer for this one. Subha, Anant, Mansi, Chinmay Roy. Okay, let me know that. What is the answer for this question? Give me 1 minute. This is the second question. Okay, then what is the answer for this one? Now, the conductivity sigma as a function of 1 by T, where T is the temperature for semiconductor material, varies as shown in the figure. Using this information, state whether a resistance made from intrinsic semiconductor will have. Now guys, remember, when we are increasing the temperature, actually it is 1 by T. Actually it is what? 1 by T. So when we are increasing, we have to move in this direction. So when we are increasing the temperature, what about the 1 by T? 1 by T decreases. 1 by T decreases, therefore new hole electron pair generated. EHP, electron hole pair, increases. So initially ionization will occur, that is called extrinsic ionization. Then almost the conductivity will remain same, and after that intrinsic excitation will start. After that, this is the, because the conductivity increases because of intrinsic excitation. Why we are having the constant conductivity here? Because 100% extrinsic excitation over here, right? And that is the case, means what is it represent? From intrinsic semiconductor will have a negative temperature coefficient of resistance. Negative temperature coefficient of resistance means temperature increases, new hole electron pair generated, concentration of electron increases, concentration of hole increases, therefore resistivity decreases, resistance decreases. That's why resistance has negative temperature coefficient of resistivity. Okay, and that is the property with increase in temperature. So right answer is B, negative temperature coefficient of resistance here, right? So watch the graph carefully. Actually it is not T, it is what? 1 by T. And you have to move from right side to what? Left side. Right side to left side, then you will get the idea about this graph. Okay, so that is the second answer. Yes, Mansi, your answer is correct, B. Then next one, next question, again from EDC. And in a quartz crystal, circuit as shown, resonant frequency variation over time with the crystal is. Right, concept of EDC, but the application in what? Analog. That is what? Oscillators, sinusoidal oscillators. You have all heard about what? Windbridge oscillator, RC phase shift oscillator, and then what? Colpit oscillator, Hartley oscillator, and one is what? Crystal oscillator. The most stable one is the crystal oscillator, and that is what? Internal or equivalent diagram of the crystal oscillator. In a quartz crystal circuit as shown, resonant frequency variation over the time with the crystal is. Okay everyone, give me the answer. What about the variation in the frequency with the time? Right? So wow, you have idea about the property of the crystal. Then tell me what is the answer. Okay, Mansi, what is your answer for this particular question? Now your comments are visible to me. Now, in a quartz crystal circuit as shown, resonant frequency variation over the time. For example, what is the quartz crystal? That crystal oscillator. In case of crystal oscillator, quality factor is very high. And because of this quality factor, frequency stability is very, very high. Right? So that's why with time, the variation in the frequency is very, very low. So which answer is correct? C answer is correct. and there is a figure of merit. What is the figure of merit of the crystal or any oscillator? That is called given by d theta by d omega. What is the change in theta with respect to what change in the frequency? And that is almost, this is what d theta, variation in the, there is a variation in the theta, but to counter it, the variation in the frequency is almost zero, and that's why ideally it is infinite, and for crystal oscillator it is very, very, very high, guys. So what is the answer for this question? Very, very low. Frequency variation, this is the, it is talking about the frequency variation. Variation is negligible. Variation is almost negligible. Okay, so that is the answer C. Now, next question. That is the question on what? MOSFET. Okay, question on MOSFET. The double the drain current, to double the drain current of N channel enhancement mode MOSFET biased in saturation. To double the drain current of an N channel enhancement MOSFET biased in saturation. So what is the formula for the saturation drain current? Half of K and S W by L VGS minus VT the whole square. Now what is here? Channel length should be doubled. If suppose everything is constant and we are making L what 2 times, it is inversely proportional to L, then the current will become half. Current will become half. Right? That will not work. Channel width should be halved. If you are going to W, you are going to make the W half. Again the current will become half. It will not work. Channel length should be halved. Yes, when we are making the L is equal to L by 2, we are decreasing the length, current will increase. Right? Because it is inversely proportional to L. Remember, we are keeping VGS constant, VT constant, K and S. K and S is nothing but mu n COX. Mu n COX. It is constant. And that's why the right answer for this question is channel length should be halved. Okay? And remember, COX. What is the COX? Epsilon naught X by TOX. So, oxide thickness should be double. If you are going to make the oxide thickness double, this is double, then what will happen? K and S will be what? Half. When the K and S will become half, current will become half. And that's why D option is also wrong. Only the C is the correct one. Right? Now, okay, tell me what is the epsilon R for SiO2? What is the epsilon R relative permittivity for SiO2? Give me the answer in comments box. Next question. Next one. Now, next question again. In an N-type gallium arsenide semiconductor at temperature 300 degree Kelvin, the electron concentration varies linearly from 10 to the power 16 to what 10 to the power 17. Okay, that means what? Linearly. So means it will increase like this. 10 to the power 16 to what? 10 to the power 17. Means that is not uniform. Means it is a non-uniform, and electron will move from higher concentration to what? Lower concentration. So electron will move in this direction. When the electron will move in this direction, current will move in opposite direction. So current will move in positive X direction, and that is called Jn. Diffusion current density Jn. Slope is positive. This slope is what? Positive. And what is the diffusion current density? Q dn dn by dx. Q dn dn by dx. Now you can put Q 1.6 into 10 raised to power minus 19, because what is asked? Diffusion constant is given. If the electron diffusion coefficient, then the electron diffusion current density. So tell me what is the answer? A, that is the 36, B 360, C 72, D 720. So you can use this formula. What is the Q 1.6 into 10 raised to power minus 19? Dn 1250. And what is the dn by dx? Slope. Slope means y2 minus y1 upon x2 minus x1. So what is the x2 minus x1? This distance is what? 0.5 centimeter. That we are assuming it 0. So x2 minus x1 will become 0.5, and that is the 10 to the power 17 minus 10 to the power 16. So you can write like that, 10 to the power 17 minus 0.1 into 10 to the power 17. Because we can write like 10 to the power 16 is equal to upon what? 0.5. Now without calculator you can calculate it. Without calculator you can solve it. That will become 0.9, 1250 into 1.6, multiply it, and that will 1.5 will become 2. Right? 1 by 0.5 will become 2. To multiply everything and then you will get answer A. 36 ampere per centimeter square. And that current will be in positive X direction. Because electron will move from higher concentration to lower and the current will move in what? Positive X direction. And that's why we are getting the positive value of the current. Okay. This is again very important question from what? EDC on diffusion current, guys. Now next question. Next one. This is the next question. Superconductors are becoming popular for their use in. Why we are using the superconductor? And that is the question from material science and what? Basics of EDC. So what is the answer for this question? To learn about the superconductor, you will get the question from this topic, that is what? Material science in HAL. Because in HAL, material science, that subject is important. Then what is the answer? Generating very strong magnetic field. You heard about what? Maglev train. You heard about what? MRI machines. So we are using what? Very, very strong magnetic field there. Second answer is manufacturer of bubble memories, generating electrostatic field, generating region free from magnetic field, guys. Are become popular for their use in. Why? They are highly popular. What is the answer, Mansi? And answer for this question is A. That is because of what? Magnetic field. Generating very strong magnetic field. This is the superconductors. That is the application of superconductor. Okay. Now next. Okay. Now try to solve some numericals also. So Abhishek, your answer is also correct. The transistor used has beta naught is equal to 100. R, that is 1 kilo ohm, R pi, and R naught is equal to infinite. Determine the value of FL. Determine the value of FL. That is the question from analog. FL means lower cutoff frequency. And we are getting the lower cutoff frequency because of this coupling capacitor. So there is only one coupling capacitor CC. Then what is the value? Now tell me what is the answer for this question. Okay, everyone. 1 minute. Please try to solve that question. Just okay, tell me what is the answer. This was the question. Sir, answer is close to 2.7 hertz, Abhishek. Okay. Now, watch this. If you want to solve this question, then this is the coupling capacitor, outside coupling capacitor. This is given. This is RC. This is VCC. This is RL. And what is the lower cutoff frequency because of this coupling capacitor? That is given by 1 by 2 pi RC plus RL into what? CC. Outside coupling capacitor, that is the CC. Right, this and that. Now it will become 1 by 2 pi. This is the 4 plus 2, 6 kilo ohm into 10 raised to power 3 because it is in kilo ohm. And what is the CC? That is given as 10 microfarad. 10 into 10 raised to power minus 6. Now use this and calculate it. When we are calculating, you will get the answer for this question. So you are getting which answer? It is around what? Hertz. It is not kilohertz. No? It is in hertz answer. That is the 2.65 hertz, guys. Remember, lower cutoff frequency means what? This is the curve. This is the frequency response of RC coupled amplifier. And this lower cutoff frequency we are getting because of the coupling capacitor CC1 and CC2. Right? And that is the reason we are calculating the FL in terms of what? CC, that is outside coupling capacitor. Yes, that is the correct answer for this question. So please revise all this topic. Next one, next question. For the given circuit, the transfer characteristics are, what is the transfer characteristics for this particular circuit? What is the name of this circuit? We are having the two diodes D1 and D2, that R2 and R1, right? And this R2 and R1 are equal. Then what is the name of this diode? And guys, remember, in this particular circuit, operational amplifier is ideal. But what about the diode? Diodes are practical. Diodes are practical. We have to assume the practical diodes. And you can assume operational amplifier ideal. Because of the practical diode, we have to design this circuit. And what is the name of this circuit? The name of this circuit is yes, tell me what is the name of this circuit? Okay, now I am going to explain this. This is a precision rectifier, guys. This is a precision rectifier. These resistors are equal and here we are giving the input. Then when Vs is greater than 0, because of 180 degree phase shift, you will get at this point negative voltage. When this VA is negative, diode D1 is off, D2 is on. Or always remember, when D1 is off, then V0 will be 0. And then when Vs is less than 0, this voltage will become positive. Because of 180 degree phase shift, it will become positive. So this diode is on, this diode is off. And when this diode is on, it behaves like what? Inverting operational amplifier. It behaves like inverting operational amplifier, and because of this diode. And in negative half, the output will become minus R by R into what? Vs. And that is nothing but minus Vs. Minus Vs means we are having the 180 degree phase shift. So this is minus Vs. Now, when it is minus Vs means you are having, for example, if you are having the sinusoidal output, okay, then for positive half we are getting the zero output, and for negative half we are getting the negative output. Negative means input is negative, then output will become positive. That's why it is called inverting half wave rectifier. Here you will get the zero output, here you will get the positive output, zero output, positive output, right? And that's why what is the transfer curve? In positive half we are having zero output. This is the positive half, this is the output, this is the Vs. Or in negative half, when the input is negative but output is positive, means we are having the negative slope. So that is the case. And what is the slope? Because V0 is equal to minus Vs, you can compare with Y is equal to Mx plus C. This is the equation of line. So what is the slope? Minus 1. And what is the interception? 0. What is the slope of this line? Minus 1. So that is in first, second, third and fourth. So it is in what? Second quadrant. It is in second quadrant. Now tell me which answer is correct. Which answer is correct for this question? B. V0 upon V in, that is the transfer curve. Perfect transfer curve, V0 by V in. Right? So this is the D1 is on, then there will be the output. When D2 is on, D1 is off, there is zero output. This is a precision rectifier. So directly they will give you the question within 1 minute you can solve, because it is a standard answer. Then next question is on, already we have solved one question on what? Crystal oscillator. Now that is the question on RC phase shift oscillator. So okay, tell me what is the answer for this one? RC phase shift oscillator, what is the answer? Now consider the phase shift oscillator as shown in the figure. RC, 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 and operational amplifier is connected here, and that is the feedback. If the frequency of oscillation of the circuit is 100 kilohertz, then the value of resistance R, what should be the value of the resistance R here? Okay, then you can find a value. You can find a value by using formula. The frequency of oscillation F0 is given by 1 by 2 pi, right? Root 6 or RC root 6. RC root 6. What is the value of the C? 100 picofarad it is given. You have to find the value of the R, and the frequency is given as 100 kilohertz. 100 kilohertz means 100 into 10 raised to power 3. 1 by 2 pi. You have to find the value of R into, what is the value of the C? 100 picofarad. That is the value of the C is given as 100 picofarad, 10 raised to power minus 12 and root 6. Okay. You can find, what is the, you have to find the R. You have to consider only 1 by pi, means always remember what is the value of 1 by pi for this type of questions. So, okay, tell me what is the answer for this one? Calculate it, and what is the answer? Everyone. क्या होगा भाई आंसर? तो R here, shift here, right, and get the value of 1 by 2 pi or 1 by pi, and what is the 1 by pi root 6? Approximately you can find the value. Always remember there is a huge difference between the answer. So that 2.4, 6.5, 1.9 and 4.7, and you will get the answer B. You will get the answer B for this particular question, guys. Any doubt up to this point? Okay. So the straightforward question, formula based question, because within limited time you have to solve large number of questions, guys. Okay, 1 mark question hai according to the previous pattern. अब जो लेटेस्ट पैटर्न आएगा वो आपको पता चल जाएगा, लेकिन आपको बहुत सारे क्वेश्चन सॉल्व करने हैं बहुत ही कम समय में। तो आप देखिए कि स्ट्रेट फॉरवर्ड और कैलकुलेशन, एक जो भी आपके पास 4 ऑप्शंस हैं उसके हिसाब से आप कैलकुलेशन कीजिए तो आप आंसर निकाल सकते हैं कि हाँ ये टेंटेटिव आंसर ये आएगा। तो ये है वैल्यू। नाउ नेक्स्ट वन, 10 millivolt input to an amplifier gives 10 volt output without feedback. Without feedback. With a negative feedback, 200 millivolt input is required to get the same output. What is the feedback factor? So guys, when we are solving this type of question, quickly draw the diagram. Without feedback, with feedback, so that you can understand what is asked in the question. This is A, this is beta, this is negative feedback. So what is given? When we are giving the 10 millivolt as an input, what is the output? 10 volt. So what is the value of the A? A is given by output upon input. That is 10 divided by 10 into 10 raised to power minus 3, and you will get the 1000. 1000 is the value of A. Now what is written here? With negative feedback. With negative feedback, 200 millivolt input is required to get the same output. So what is the same output? 10 volt. So that is the output with feedback. Again we are getting the 10 volt. And we have to give, what is the input here? 200 millivolt. So what is the overall gain of the system? That is called feedback gain. Gain with feedback. That is given by 10 divided by 200 into 10 raised to power minus 3. Then solve it, you will get the gain 50. Means after feedback, the gain will become what? 50 only. From 1000 to 50. Because we have to increase. So how much time we are increasing the gain input? Around 20 times. When suppose we have to increase the input by 20 times to maintain the same output, means gain is reduced by what? 20 times. So what is the 1000 divided by 20? You can directly get this answer quickly, that is the 50. So new gain is 50, and what is this? A upon 1 plus A beta is equal to 50. So what is the 1 plus A beta is equal to? A upon 50, that is nothing but 1000 upon 50. And that will become 20. Already I have find, this is called desensitivity. Desensitivity. Then 1 plus 1000 beta is equal to 20. So what is the beta? Is equal to 19 divided by 1000. So what is the beta in percentage? 19 divided by 1000 into 100. And that will become 1.9%. That will become 1.9%. Very small negative feedback. And because of very small negative feedback, gain reduces from 1000 to what? 50. Reduces from 1000 to 50, 20 times. So guys, what is the new thing in this question? If the gain reduces by the 20, then you have to increase the input by what? 20 times to maintain the same output. Okay, same output. Okay, give me the answer in comments box. What are the advantages of the negative feedback then? Why we are applying the negative feedback? Because of negative feedback, gain decreases. We have to increase the input to maintain the same output. Then what are the advantages of negative feedback? Okay, then the answer is 1.9A. Answer is 1.9A. Next question. That is on what transistor? That is on what transistor? Again the question from analog. Quickly give me the answer. Okay then. Consider the circuit shown in the figure below. This is the 15 kilo ohm, 10 kilo ohm, 5 kilo ohm, 0.7 volt, minus 10 volt. Assume that the beta of the transistor to be very large. Always remember, when we are considering beta is very large as compared to 1, then we can neglect the base current. Let it is nearly equal to tends towards 0. And we can say IC and IE are nearly equal. IC is nearly equal to what? IE, because we are neglecting the base current. Right? Yes, Mansi, your answer is correct. We are getting high bandwidth when we are giving the negative feedback, gain decreases, bandwidth increases, and circuit will become more stable. More will be the bandwidth, more will be the stable circuit. Now, assume the beta of the transistor to be very large. The value of the collector voltage Vc. What is the value of the collector voltage Vc? Is equal to 6.1, 2.43 and minus 4.475, and D is equal to minus 2.21. Now, for this particular question, when the beta is very large, you can neglect the base current. You can neglect the base current. Then, what is the current here? IC. What is the current here? IC plus IB. This current is IB, but we are assuming that IB is nearly 0. Again, what is the current here? IC plus IB. That is nothing but IC. IC plus IB is nothing but IC, or IC is nearly equal to IE. Now you can write the KVL from this point to this point. You can write the KVL to find the value of the IC. What is the value of the IC? 10 volt. KVL 10 volt is equal to 15 times of IC. Neglect the IB. IB is 0. No need to consider the drop across 10 kilo ohm. 0.7, that is nothing but VBE plus 5 times of IC. This is minus 10. And you can write the IC is equal to 20 minus 0.7 upon 20. This is the 20 minus 0.7 upon 20. That is 19.3 upon 20 milliampere. That is the value of IC. Now, what is the value of the VC? You can find the VC 10 minus 15 times of IC. 10, this voltage VCC minus drop across the 15 kilo ohm, that is written as 15 times of IC. So it will become 10 minus 15 into 19.3 divided by 20. It will become 3 by 4, or you can solve it and you will get what? Negative value. You will get, definitely it is what? Negative value, and is nearly equal to what? Minus 4.475. Minus 4.475, and that is the answer for this question. So without calculator you can solve this question, okay? Without any calculator you can use, okay, right? Now, next one, next question. This is the question from the analog. Question on 555 timer. Question on 555 timer. This is the standard diagram of 555 timer in what? Astable mode. Astable mode. Means square wave generator. Square wave generator. Pin number 4, pin number, okay, tell me what is the number, pin number in 555 timer first of all. That may be the question. It is a 8 pin IC. 1, 2, 3, 4, 5, 6, 7, 8. Okay, give me the name of pin number 2 and pin number 6. Pin number 1 is ground. Pin number 3 we are taking the output. Pin number 4 is reset. Give me the name of 2 and 6. Pin number 5 is called control voltage. We can control the timing by applying the voltage at this point. Pin number 7 is called discharge. And pin number 8 is called supply, VCC. Normally we are giving the 5 volt supply in 555 timer. Now what is the pin number 2 and pin number 6 within 20 seconds? Everyone, pin number 2 and pin number 6. Then this is a 555 timer. So when 4 and 8, normally we are connecting the reset pin with the 8 pin. It is connected here. This point is connected to what? Pin number 7. And the voltage across the capacitor is connected to pin number 6 and 2. And normally when the pin number 5 is not in use, it should be bypassed through a 0.01 microfarad capacitor. So that is connected to ground. This is standard answer is this is RA, this is RB, and this is C. And that is the standard circuit of astable mode. What is the frequency of oscillation? FC. Frequency of oscillation is given by 1 by, right, 0.693. RA plus 2 RB into what C. That is the formula. 1 by T. This is the, what is the time period here? T is equal to T on plus T off. And that is the time period. 0.693 RA plus 2 RB into what? C. Now you can find the value, and guys remember this all answer in kilohertz. All answers are in kilohertz. The frequency of oscillation is 5.2, 5.7, 4.3, 3.5. Right, put the value of RA 1 kilo ohm, put the value of RB 2 kilo ohm. So 2 plus 1 you will get the 5 multiplied with the 0.693, and then C is what? 0.05 microfarad. And then find the reciprocal of that. Reciprocal of this. 2 is trigger, Mansi, and 6 is what? Threshold. Yes, your answer is correct. And you will get nearly equal to what? 5.7. Nearly equal to 5.7, guys. This is the B. 5.7. Now, kilohertz. It is the answer in kilohertz. You can verify by putting the values in the formula. This is the astable mode. And pin number 2 is what? Trigger pin. And pin number 6 is threshold. Pin number 6 is what? Threshold pin. Okay. Then, next question. At IC is equal to 1 milliampere and VC is equal to 10 volt. High frequency parameter at cutoff frequency FT 500 megahertz. FT is nothing but gain bandwidth product. It is called unity gain bandwidth product. That is the property of amplifier. So yes, unity gain bandwidth product was measured at C mu 10 picofarad. The value of the C pi. What is the value of the C pi will be equal to? Assume Vt is equal to 25 millivolt. So there are option 1.6 picofarad, 2.1 picofarad, 2.7 picofarad, 3.4 picofarad. Again that is a formula based question. कोई कुछ दिमाग नहीं लगाना, आपको बस फॉर्मूला अगर मालूम है तो आप इसको कैलकुलेट कर सकते हैं. देखो ये है स्ट्रेट फॉरवर्ड क्वेश्चंस. और गेट एग्जाम और इसमें क्या अंतर है? गेट एग्जाम में ना आपको क्वेश्चन को सॉल्व करना होगा और आपको 3 घंटे में ओनली 65 क्वेश्चंस बनाने. और इन एग्जाम्स में क्या होता है? स्ट्रेट फॉरवर्ड फॉर्मूला बेस्ड क्वेश्चन आएगा, थोड़ा कैलकुलेशन करना पड़ेगा, तो कैलकुलेशन थोड़ा फास्ट कीजिए आप लोग. राइट, तो देखते हैं जरा. FT, अगर आपको मालूम है व्हाट इज द यूनिटी गेन बैंडविड्थ प्रोडक्ट, FT इज नथिंग बट GM अपॉन, राइट. अब GM अपॉन क्या है? 2 पाई C पाई प्लस C म्यू. You can use this formula and you can find the C mu is given in the question. You can find the C pi. Now what is GM? This is called transconductance GM. GM is given by mod of IC upon what? VT. So what is the IC? It is given 1 milliampere. And what is the VT? The number of students will use this 10 volt. That is wrong. It is not VT. What is the VT? Volt equivalent of temperature, 25 millivolt. It is in milliampere. It is in millivolt. Milli cancel and it will become what? Ampere per volt. 1 by 25 ampere per volt. Remember, unit is very important. Now put the value of GM here, 1 by 2 per 25. Put the value of the C mu. Put the value of the FT, that is the 500 megahertz. 10 raised to power 6 is equal to GM 1 by 25 upon 2 pi C pi. You have to calculate the C pi. C mu. You can keep in what? C mu in what? Picofarad. So you will get the answer in what? Picofarad. First of all, find the value of the C pi plus C mu from this formula, and then you can find the C pi. Okay, arrange this values, guys. Okay, so that is the value, and now you will get around 2.7 picofarad. 2.7 picofarad. So this formula is important. GM upon 2 pi C pi plus C mu, and what is the value of the GM? mod of IC upon VT. You have to use this formula. अब जरा बताना, अभी तक हमने जो क्वेश्चन सॉल्व किए हैं ज्यादातर क्वेश्चन क्या है, फॉर्मूला बेस्ड है, लेकिन फॉर्मूले के साथ साथ आपको कैलकुलेशन भी फास्ट करना है. अब आते हैं क्वेश्चन ऑन ऑपरेशनल एम्पलीफायर. फॉर द सर्किट शोन बिलो द वैल्यू ऑफ I2 by I1. Where is the I2? It is the I2. Where is the I1? This is the I1. And this is the, if the thing is given, operational amplifier is ideal, then for the circuit shown below the value of I2 by I1. Right, tell me. यार ये तो बहुत बार आपने बनाया है, आप अपना टाइम लीजिए और बताइए क्या होगा. What is the answer for this question? What is the answer for this one? Yes, please. क्या होना चाहिए आंसर? तो देखिए, ऑपरेशनल एम्पलीफायर यू कैन एज्यूम व्हाट, ऑपरेशनल एम्पलीफायर आइडियल. When operational amplifier is ideal, this voltage is 0, this voltage is 0. Now I1, the same current I1 will flow like this. Same current I1 will flow like this. Then if it is 0, there are two ways to solve this question. I am just giving you the very, very easy method. Now guys, this is ground, that is ground. And this is what I2. The same current, because the voltage at this point is same, voltage at this point is same from this point to this point, from this point to this point, and that's why it will give the same current I1 here. I1 will flow from this, I1 will flow from this, because the resistance are same, voltage is same. So this is I1, this is I1, so it will become 2 times of I1, and 2 times of I1 is equal to I2. 2 times of I1 is equal to I2. So what is the I2 by I1? I2 by I1 directly you can say 2. So within seconds you can solve this question. I2 by I1 is equal to what? 2. So what I am doing, according to virtual short concept, this voltage is 0. This voltage is 0. Voltage at this point is same. So therefore, if in this branch the current is I1, so what is the in this branch? Because the potential is same, the current will remain same, I1, I1. Now this I1, it will become 2 times of I1. When we are giving the 2 times of I1, that is nothing but I2. So you can say I2 is equal to 2 times of I1. So what is the I2 by I1? That is the answer is what? 2. Answer is 2, D. Or otherwise you can apply the KCL at this point, KCL at this point, but that will make the question lengthy, solution lengthy. Okay, it is a tricky question. Directly you can solve within 30 seconds. So this is the answer. Now next one. Oh, this is the question on what? Differential amplifier. This is the question on differential amplifier. In my number of sessions, I have taken the this topic, differential amplifier. How to find the AD, how to find the AC, how to find the CMRR. That is the question. What is the question here? Consider the differential amplifier as shown in the figure. Assuming the op-amp to be ideal, the CMRR, common mode rejection ratio of the circuit is equal to common mode rejection ratio. What is the method? Under ideal condition, common mode rejection ratio is infinite, but that is not infinite. 4 options are not infinite. First of all, you have to check this ratio, R2 by R1. So what is the R2 by R1? 10. And what is the R4 by R3? 11. This ratio are not equal. R2 by R1 is not equal to what? R4 by R3. And that's why this is not an ideal differential amplifier and AC is not 0. CMRR is not infinite. So what is the CMRR? Common mode rejection ratio. It is given by 20 log of, because it is asked in dB, mod of AD by AC. Mod of AD by AC. AD is called difference gain, AC is called what? Common mode gain. So AD by AC. Now what is the standard formula for this? Remember, if that operational amplifier is given, you can find the V0 is equal to 1 plus RF by R1. RF means this one is the RF, R2 by R1. 1 plus RF by R1 into voltage division rule at this point, R4 upon R3 plus R4. R4 upon R3 plus R4 into non-inverting terminal voltage. What is the non-inverting terminal voltage? V2. This is the non-inverting terminal voltage V2. Then minus R2 by R1 into V1. That is inverting terminal voltage R2 by R1 V1. Like this is the gain A, this is the gain A2. So you can say what is the A1 is equal to 1 plus R2 by R1, R4 upon R3 plus R4, and then A2 is equal to minus R2 by R1. What is the R2 by R1? I have find the 10, it will become 10 plus 1, 11. And what is the R4 upon R3 plus R4? 1 plus 10. R4 it is given 11 kilo ohm. 11 divided by 1 plus 11, 11 by 12. That will become 11 into 11 divided by 12. That is 121 by 12. And what is the minus R2 by R1? It will become 10, minus 10. So what is the AD? AD is A1 minus A2 by 2. That will become 121 divided by 12 plus 10 divided by 2. 120, 121, 241 divided by 24. What is the AC? AC is nothing but A1 plus A2. A1 plus A2. So it will become 121 divided by 12 minus 10, because A2 is minus 10. So it will become 1 by 12. 1 by 12. Now 241 divided by 24, 1 divided by 12. Put these two value here, AD by AC, and find the 20 log of that value. When we are finding the 20 log of that value, you will get answer 41.6 dB. 41.6 dB. So remember, this is the, no doubt this question is what somewhat lengthy, but if you have idea, directly you can find the A1 and A2, and then from that you can find the AD and AC, and then you can find the CMRR, common mode rejection ratio. So this is the question. Answer is B for Bombay. Now next one, for a n-channel MOSFET biased in the saturation region, the parameter mu n COX W by L, half of mu n COX W by L it is given. Threshold voltage is given as 0.8 volt. Lambda, this is called channel length modulation factor, 0.01. If the value of the drain current flowing inside the MOS transistor is 0.75 milliampere, ID is also given. Then the value of intrinsic gain A0, GMR0. GMR0. It is asked, what is the GMR0 of the MOSFET is? GMR0. So there are four options, 201, 115, 143 and 163. So you can solve by using these two formula. GM. What is the GM? K and S W by L VGS minus VT, right? And what is the formula for IDS? Half of K and S W by L VGS minus VT the whole square. VGS minus VT the whole square. From this you can find the VGS minus VT. VGS minus VT will become root over 2 times of IDS upon K and S W by L. Right, VGS minus VT. Put this value in this first equation. Then you can find the new formula for GM. It will become root over 2 times of K and S W by L IDS. That is the formula. Put this in that and you will get the 2 times W by L IDS. You have the value of what? K and S means GM is equal to root over 2 mu n COX W by L into IDS. Now this mu n COX W by L. It is given in the question. This is the mu n COX W by L. It is nothing but 1. This 2 is multiplied. So mu n COX W by L will become 1 milliampere per volt square. And what is the value of the I? I is also given 0.75 milliampere. So from that you can find the value of what? GM. Right? Find the value of the GM. Then how you can find the value of R naught? Output resistance because of channel length modulation. This is called early voltage divided by ID. And what is the early voltage? 1 by lambda ID. Lambda. 1 by lambda is what? 0.01. And ID it is given as 0.75 milliampere. 0.75 milliampere. What is the unit of the lambda? Per volt. So yeah, it will become what? Kilo ohm. Resistor will be in kilo ohm. Now you have the value of the GM, you have the value of the R naught. Then you can find the value of what? GM R naught. You can find the value of GM R naught. And that is all the formula we have used for that. And you will get 163.3. 163.3. क्या होगा पता है? इस न्यूमेरिकल में कई लोगों को लगेगा सर VGS माइनस VT निकाल के फिर हम इसको यूज करेंगे. जरूरत नहीं है. डायरेक्टली यू कैन यूज दिस फॉर्मूला फॉर GM. दिस इज इंपॉर्टेंट फॉर्मूला. We are getting the GM from these two formula. And then directly everything is given, then you can directly use this formula and find the R naught from the channel length modulation. And what is the internal gain? GM R naught. Now you can find. Then again question on MOSFET. Consider an NMOS transistor shown in the circuit below. Right? What is the consider NMOS transistor? NMOS, acha, you are giving the 163.3. Yes, that is the correct answer, 163.3. Consider an NMOS transistor shown in the figure. Now what is this is the N channel MOSFET, this is the line. N channel MOSFET, 5 volt minus 5 volt. VG is 0. You have to find the VS. To find the VS, you have to find the VGS. And then VD. And this is called VDS. So VD is 5 volt. VD is directly 5 volt. If you are going to find the VS, you can find the VDS. What is the VDS? VD minus VS. 5 minus VS. What is the value of the VS? Now, the NMOS transistor is so constructed that it has mu n COX W by 2L. That is nothing but, this is the K and S, mu n COX W by L, and half of that. 0.5 milliampere per volt. The threshold voltage is 1.2. Lambda is 0 means there is no channel length modulation. Neglect the channel length modulation. The value of voltage VDS is equal to. Okay. Here the current. What is the current given? 1 milliampere. If the current given is 1 milliampere, then we are assuming that this is in saturation. If this is in saturation, how we can say it is in saturation? First of all, guys, we can say it is in saturation because what is the value of the VD? 5 volt. What is the value of the VG? 0 volt. It is visible that VD is greater than VG. If the VD is greater than VG, 100% sure VDS is greater than VGS. If the VDS is greater than VGS, VDS is greater than what? VGS minus VT. Means it is in what? Saturation. It is in saturation region. Because of this logic, it is in saturation region. In saturation, you can apply the formula IDS is equal to half of mu n COX W by L VGS minus VT the whole square. Now, what is the IDS? IDS is the 1 milliampere. Same current will flow because the gate current is 0. So 1 milliampere is equal to, what is the value of this term is given? The value of this term is given as half of mu n COX W by L 0.5. Half of mu n COX W by L 0.5. So you can use the 0.5. And what is the threshold voltage given? 1.2. This is 0.5 VGS minus 1.2 the whole square. Then it will become 2, and this is a root 2 is equal to VGS minus 1.2. And it will become 1.414 plus minus, but you have to choose the plus value. So what is the VGS? 1.414 plus 1.2. Because if you are choosing the minus value, it will become less than the threshold voltage. Or if the value is less than threshold voltage, means it is in cutoff. That's why you have to choose only the positive value. When we are choosing the positive value, VGS will be greater than the threshold, and answer is 2.614. This is the value of VGS. This is the value of VGS. But what is the VG? 0. So VGS is nothing but VG minus VS. So VG is 0. 0 minus VS is equal to what? 2.614. What is the VS is equal to? Minus 2.614. Now if you have the value of VS, then you can put value of the VS here. 5 minus of minus 2.614, and it will become 7.614. 7.614. A is the correct answer for this question. It is visible to you? A, 7.614. That is the value of what? VDS, drain to source voltage and transistor, that MOSFET. It is in saturation region. Quickly you can solve this question. Okay. The next one. Next question is on what? Zener diode, that is on voltage regulator. Consider the Zener diode circuit shown in the figure below with VZ is equal to 6 volt. This is the VZ, 6 volt, and 0 Zener resistance, RZ is 0, and knee current of 5 milliampere. Knee current of 5 milliampere. The minimum value of R so that the voltage across it does not fall below 6 volt. What is the minimum value of R? You have to find. Minimum value of R. Yes, when we want this voltage should remain constant, 6 volt means Zener diode should remain in what? Breakdown region. So there are current I. It is divided into two current IZ and IL. Then you can find the IZ is equal to I minus IL. I minus IL. And what is the IZ minimum? IZ minimum will become I minimum minus IL maximum. And that current should be greater than or equal to what? IZK. That current should be greater than or equal to what? IZK. Now, how you can find the I minimum? I minimum is nothing but V minimum minus Vz, because at this point voltage is fixed. V minimum minus Vz upon that R will give you series resistance, will give you the I minimum, but this is fixed. Then you have to use the 10 volt. And what is the IL maximum? IL maximum is nothing but Vz upon RL minimum. This is the, you have to find the RL minimum. This is the load resistance. Vz upon RL minimum will give you the IL maximum. Use this formula. Use this formula. It will become I minimum. What is the I minimum? Vi minimum minus Vz upon R. And what is the IL maximum? Vz upon RL minimum. And that current should be greater than or equal to knee current. It is fixed. It is 6. RS is 50 ohm minus VZ 6. You have to find the RL minimum. It should be greater than or equal to IZK. What is the IZK? Knee current 5 milliampere. Because you are using the resistance in ohm, current, convert the current in what? Ampere. So 5 milliampere is nothing but 5 into 10 raised to power 3 minus 3 milliampere. Convert the milliampere into ampere. Now, this is the 4 by 50 minus 6, and then you can solve it, and from this you can find what is the RL minimum. It should be greater than or equal to, you will get the value from this inequality. So what is the answer? What is the answer, guys? This is the question on Zener diode, right? And from that you will get the, it should be greater than or equal to what? 80 ohm. From this inequality, you will get 80 ohm. This is the answer. 80 ohm. This is question on Zener diode. So this already in one of my session in what Trichopedia. So subscribe the channel and go through the our Trichopedia series where I have taken the session on what voltage regulator. Within 5 minutes you will get the idea about the complete voltage regulator, how to use this formula. And I have taken the session on what precision rectifier on Trichopedia. So on this same channel, subscribe the channel so that you will get the idea and watch those session on Trichopedia. Okay. Then next one. Regulated output voltage for the following circuit will be. What is the regulated output voltage here? This is a standard circuit. General diode should be in breakdown region. Operational amplifier with negative feedback. BJT should be in what active region. This is the voltage regulator. What is the current enter into the operational amplifier? 0. So what is the current at this point? Virtual short concept. VP is equal to VN. The voltage at this point is Vn. It is nothing but Vp. And what is the Vp is equal to Vz? Because it is in breakdown voltage. This is the 6.2 volt. And according to voltage division rule, what is the voltage at this point? 10 divided by 10 plus 30 into V0. And that is nothing but Vz. So what is the V0 is equal to 10 plus 30, 40 divided by 10 into what Vz? 4 into Vz. What is the Vz? 6.2. It will become 24.8. Very, very, very easy question within 30 seconds. 24.8 volt. That is called what? Regulated voltage. Okay. This is a regulated voltage, guys. Next one. So this is again a standard. So this is the question from what? Analog. So hope you have enjoyed. Now tell me what is the answer for this question. What is the answer for the next question, guys? Everyone. Okay, बताइए जरा क्या होगा आंसर. Hello. Okay. Now tell me. Consider the following statements relating to cavity resonator. So that is the question from what? Microwave. The cavity resonator does not possess as many modes as corresponding waveguides, right? But that is the wrong statement. Cavity resonator have as many modes as the corresponding waveguide does. तो जितने waveguides में उतने ही mode almost किसमें होते हैं? Cavity resonator में होते हैं. So that is what about the first point? That is what wrong point. Second, the resonant frequencies of the cavities are very closely spaced. Resonant frequencies of not, that is again not the right statement. Get the detailed idea about what cavity resonator, because it is very important topic. Again that is wrong. The resonant frequency of the cavity resonator can be changed by altering its dimension. Yes. When we are changing the dimension of the cavity resonator, resonant frequency will change because it depends upon its physical dimension. Okay. तो हम लोग क्या करते हैं? Size of component. When we are reducing the size of the component, L decreases, C decreases, frequency increases. 1 by 2 pi root over LC. That is the resonant frequency. When we are reducing the size of the component, L decreases, C decreases, frequency increases. So that is the C. Third answer is correct. 3 only. Then next, underlying principle of working of a cavity wave meter used to measure the frequency of microwave in a system. Okay guys, I will arrange one extra session for what? Microwave. Okay, where we will get the idea about, detailed idea about what all these topics, and that is what useful for ISRO examination, and it will be useful for what? HAL. So stay tuned with us, subscribe the channel so that you will get the notification. Underlying principle of working of cavity wave meter used to measure the frequency of microwave in a system is. So actually cavity wave meter is what? Just like what? notch filter like structure, means it will absorb that particular frequency. It will absorb that particular frequency and pass all other frequency. So it is based on what? Selective absorption of the microwave energy in the solid. If suppose you want to measure something frequency, that particular frequency will be absorbed by that and all remaining frequency will pass by that, and that is the property of what? Notch filter. Property of what? Notch filter. So this is the selective absorption of the microwave energy in solids. So you can learn selective scattering of microwave, no. Selective diffraction, no. Resonance of the cavity with incoming microwave energy, no. Selective absorption, that is the working principle of cavity wave meter. Then now guys, stay tuned with us, because now the Saket sir will join and that is the last question. Okay, and then after that Saket sir will join. So stay tuned with us and he will discuss the important questions from what? Important topic, MFT and communication. The main purpose of inserting a microwave isolator, why we are connecting the microwave isolator in microwave circuit? What we are doing here, we are connecting the source. It is a load. In between source and load, we are connecting the isolator. We are connecting the isolator, right? This is isolator and that is the source. So why we are connecting the isolator? Point, offering minimum forward impedance, that is the case, no problem, but it is not the main purpose. It is not the main purpose. Why we are connecting? Why we are? That is the question. So in this direction, it will allow the current, right? It will pass the signal, minimum impedance in this direction so that it will pass, but in opposite direction, it will give maximum attenuation. Maximum attenuation. That's why this signal is not passed. So in a source to load, the signal will flow, right? There is no attenuation, minimum attenuation, and from load to source, maximum attenuation. That's why when there is some reflected power, then it will not reach to what? Source. When it will not reach to source, the frequency will remain stable. The frequency at which source is generating power, it will remain stable, and that's why basic concept, why we are using the isolator, why we are using the circulator, that is the basic purpose of isolator in this case. So maintaining the frequency stability of the source, right? So this is the C is the correct answer. To get the idea about that, okay. So one student have given the answer, that is Mansi, you have given the right answer for this question. So stay tuned with us. Now the Saket sir will join. Okay guys, hope so you enjoy the session, like the session and share the link of this session and subscribe channel so that you will get the notification about all coming session guys. And tomorrow at 5 p.m. I will solve questions on network from engineering services pre-examination. Sharp at 5 p.m. tomorrow Saturday, right? And again we will discuss what? Questions on transient, तो वो भी important है for HAL and ISRO examination. Okay then, give me 1 minute only.
Hello, good evening everyone. In fact, good afternoon actually. This is 2:15 only. So good afternoon everyone. Welcome to BYJU'S exam prep. And as you all know that we are actually discussing the HAL 2023 EC mock test. So you all know that the EC exam, right? EC or HAL exam is going to be on the 9th of September. So for this particular exam, we have only 1 month left. So just you need to practice the as many question as possible, because in this 1 month there is no need to go into the depth of the books or the textbook or the concepts. Just you need to practice as many question as possible. what you can do is you can prepare the questions of the ISRO previous year. Okay, ISRO previous year question you can practice. That will also help you to prepare the ISRO examination. Then you can go for the HAL previous year paper. Then you can go for the DRDO previous year paper. Then you can also go for your BARC previous year paper. That means the type of questions you will get anywhere in the. Just wait a second, guys. Hello. अच्छा ये तो मेरे yes, so sorry for the disturbance because yes, once you are getting the voice now. You are getting the voice now. So let's begin the questions. This is the first question. In this question, it is saying that if the signal x1n is equal to e to the power j 5 pi n, let me write the question for you if it is not visible, suppose, then this x1n is given as e to the power j 5 pi n upon 7 plus x2n is given as, I am writing the question first. So x2n is e to the power j 2 pi n. You have to calculate the fundamental time period of this signal, x1n plus x2 3n by 4. Yes, so can you answer this question? Can you answer this question? This is the two signals x1 and x2 I have given you, and I am asking you to calculate the time period of the signal xn, which is x1n plus x2 3n upon 4. So as you can see that this x of n is equal to x1n, which is e to the power j 5 pi n upon 7 plus x2, which is e to the power j, replace n by 3n by 4. So it will become e to the power j 5 pi n upon 7 plus e to the power j 3 pi n upon 2. 3 pi n upon 2. Okay. Now, if I calculate the omega 1 for the first signal, then it is nothing but a 5 pi upon 7. And if I want to calculate the n1, then it is nothing but the 2 pi by omega 1. So it is equal to n1 is equal to 2 pi by, let's say integer is n. So this is 2 pi omega 1. Omega 1 is nothing but a 5 pi upon 7. And let us say that integer is m. So here it is nothing but a 14 upon 5 m. So if I take the integer value as 5, then the n1 I will get as 14. So this is the first thing which we are getting for the first thing. Okay. Right. Now coming to this n2. Okay, now coming to this n2. So let's say n2 is 2 pi by omega 2 into another integer n. So what is the omega 2 here? This omega 2, you can see that this is omega 2 equal to how much? This is 3 pi by 2. So 3 pi by 2. And when you solve it, you will get 4 by 3 into n. This n is thus another integer, not this n variable. Okay, this n is integer. So if I put n is equal to 3, this n2 equal to 4. So this is another time period you are getting. Now you know that how to calculate. So first of all, we will say that this n1 and n2, okay, these are rational numbers. So because these are rational numbers, so we will say that it is a periodic. So the signal is periodic. So what is the time period, the fundamental time period? That is nothing but the LCM of n1 and n2. What is the n1? n1 was 14 and this is 4. What is the LCM of 14 and 4? This is nothing but a 2 into 7. You can write, and here it is 2 into 2, or you can simply write 4 and 14. So if you say this is 28, okay, so the LCM of these two number is 28. So fundamental time period is 28. So answer would be 28. Here you can see that the correct answer is option number C. The correct answer is option number C, right? Okay. Now coming to the next question. The next question is the question number 81. Does that transform of a signal? Does that transform of a signal is given by C of Z is equal to 1 by 4. Let me write again because this is not clear. So C of Z is given as 1 upon 4 Z inverse 1 minus Z to the power minus 4 divided by 1 minus Z to the power minus 1 whole square. Okay. So you are saying that answer is 0. That's not correct. That is not correct. The answer is not 0 here. Okay. So now one answer I have got. So I am waiting for the other students also to solve this problem. What should be the final value theorem? You have to calculate the final value theorem. Apply the final value theorem, you have to calculate the final value. So can I write this as 1 by 4 Z inverse 1 minus Z to the power minus 2 and 1 plus Z to the power minus 2 divided by 1 minus Z inverse whole square. So we can also write it as 1 by 4 Z inverse. This is 1 minus Z inverse and then 1 plus Z inverse and then 1 plus Z to the power minus 2 whole divided by 1 minus Z to the power minus 1 whole square. So this will get cancelled and finally we will get 1 by 4 Z inverse and 1 plus Z inverse 1 plus Z to the power minus 2 divided by 1 minus Z inverse. Okay, this is C of Z. Now tell what should be your answer. What should be your answer? Now, can you tell? Yes, now it is 1. Now your answer has got 1. Okay, so if I substitute the value, like now we know that what is the final value theorem. So according to the final value theorem, okay, according to the final value theorem, that is your C of infinity, right? That is limit t tends to infinity and limit z tends to 1 and 1 minus z inverse C of z. So this is 1 minus z inverse and it is equal to 1 by 4 z inverse. So 1 by 4 z inverse and 1 plus z inverse and 1 plus z to the power minus 2 divided by 1 minus z inverse. So 1 minus z inverse will get cancelled and this is limit z tends to 1. Okay, so this is limit z tends to 1. Now we are left with 1 by 4 z inverse 1 plus z inverse and 1 plus z to the power minus 2. So if you will put z is equal to 1 here in this equation, this is 1 by 4 1 and this is 1 plus 1 and this is also 1 plus 1. So it is 2 into 2 divided by 4. So you are going to get the value as 1. So the answer is 1. Yes. So Harshit has got the right answer. The answer is 1. Now coming to the next question. I can give you the timer also. Okay, so Manasvi, you are saying A. That's not correct actually. So we have few more minute second in fact. So anybody can answer. Anybody else? Yeah. So the correct answer is option D. Correct answer is option D. Okay. Why it is so? In the FIR filter, remember that in the FIR filter, if Z is suppose the pole, okay, if suppose Z is 0 actually, Z is one of the zeros, okay, one of the zero, then, okay, if the Z is one of the zero, then Z complex conjugate, Z inverse and Z complex conjugate inverse all are also zeros of FIR filter. Okay, that is also 0 of FIR. So now you can see that this is 1 upon 2j. So what is the inverse of this? So this is 1 plus 2j. So 1 plus 2, 2 plus 3j. This is 2 plus 3j. This is nothing but the inverse of the z. Okay, the inverse of the z. This one. And if you take the complex conjugate, you will get 1 upon 2 minus 3j. And you will get the complex conjugate and inverse means 2 minus 3j. So 2 minus 3j, 1 upon 2 minus 3j and 2 plus 3j. So all the three options are correct. So the answer would be option D, all the four, all of the above. Yes. Now answer this one. Yes, so Ishwar has got the answer. I have more 20 seconds. So this type of question generally which has only one line, means the solution can be given in the very short time, like 30 seconds, 1 minute maximum. That type of question will be asked. For HL, so the difference answer I am getting, yes. The correct answer is option D only. The correct answer is option D. How to solve this? So if you want to calculate the energy, then energy is given by summation n is equal to minus infinite to infinite and the signal magnitude whole square. Okay, the signal here is n is equal to minus infinite to infinite a into delta n. So mod square. So delta n, that means it will have the value only at n equal to 0. So summation we have to put only at n equal to 0. This value will be defined. So it is nothing but a square. So delta n is 1 for only n equal to 0. Okay, so that is delta n, right? So this is a square. Got it? At n equal to 0 only it is defined and the value will be 1. So the value is a square. So that is the energy. Next, this question. Two systems S1 and S2 are connected in cascade. S1 is described as some function values, that is the differential equation, and about the S2 it is high pass filter, and they are connected in cascade. So you have 10 seconds left. So some guys are saying A, some are saying B. Yes. So Ishwar has got the right answer. Very good, Ishwar. So Ishwar has got the right answer again. So the correct answer is option number B. So how to solve this? Because these two are connected in cascade. So let's first calculate the y of s. So y of s, that means this one. So y of s is s into x of s plus 2 into x of s. So what is the transfer function for the first one is the y of s divided by x of s, and it is equal to s plus 2, correct? So we are getting s plus 2, right? Yes. So now coming to this second one. So what about the H2? H2 is high pass filter. So high pass filter is having the transfer function RCS divided by 1 plus RCS. So what is the RC? The time constant is 1. So RC is 1. So this is S upon S plus 1. So that is your H2S. Now because these two are connected in cascade, what will be the overall transfer function? The overall transfer function will be H of S, which is nothing but the output divided by input, equal to S plus 2, and this is S upon S plus 1. Okay, S upon S plus 1, right? And then what we want to calculate? We want to calculate the output. So output means we want to calculate y of s. So y of s is s into s plus 2 upon s plus 1 upon s plus 1 into x of s. What is x of s? The input is given as x of t is equal to e to the power minus 2t ut. So x of t is e to the power minus 2t ut. So what is the Laplace transform of this? That is nothing but a 1 upon s plus 2. So you will put s into s plus 2 divided by s plus 1 multiplied with 1 upon s plus 2. So this s plus 2 and s plus 2 will get cancelled and you will get s upon s plus 1. Now what you can do is the plus 1 and minus 1 you can perform, and hence we can write 1 minus 1 upon s plus 1. This is your y of s. Now you have to take the inverse Laplace transform. So take the inverse Laplace transform, that is y of t is equal to 1. The Laplace transform, inverse Laplace transform 1 is delta t, and this is e to the power minus t ut. So e to the power minus t ut. This will be your answer. Okay, so answer B is the right answer, correct? So understood, Manasvi? Yes. Now coming to the next one, question number 85. The Fourier series coefficient for this periodic signal. So one answer has come, that is option B, and someone is saying option D. Okay, let's see if anyone else can answer this question. You have calculated Cn, na? And according to that, I don't think that you are getting the right answer. how you are getting the plus sign in between them. How you are getting, Ishwar, the plus sign? The answers are not correct. Both the answers are not correct. I think, let's check. Yes. Now let's see whether you are correct or not. The Fourier series coefficient of this is, let's calculate, we have to calculate the value of Cn, right? The value of Cn is 1 upon the time period, integration over the time period, and the signal x of t and e to the power minus j omega, okay, e to the power minus j omega n t d t. Okay, so 0 to 1 it is a, and 1 to 2, this is 1 to 2, it is minus a. So sorry, we have to solve for this. Cn 1 upon time period, the time period is 2, the time period is 2, okay, the time period is 2, and from 0 to 1 it is having the amplitude a and e to the power minus j omega n t d t, okay, plus from 1 to 2 it is minus 1, so minus a e to the power minus j omega n t d t. The 1 upon 2 is common and a is now also common, so let's take a by 2 common, and if I integrate it, e to the power minus j 2 pi n, and omega we will replace it by 2 pi by t also later on, so 2 pi by t here, and we have n into t. Okay, let's write one more time. This is dt, and from 1 to 2 this is minus 1, right? So this is a, we have taken common, so minus 1 e to the power minus j 2 pi by t into n t, like it goes. And we know that 2 pi by t is, here t is 1, here time period is 2, so this is pi, so we have to put the value as pi. So this is a by 2, and they replace 2 pi by t by pi, and now I'm integrating it, e to the power minus j pi. 2 pi by t I have replaced it by pi. Okay, so 2 pi by t is replaced by pi, so this is pi n t divided by minus j into pi n, limit from 0 to 1. Okay, minus, this is the next one, e to the power minus j pi n t divided by minus j pi n, limit is from 1 to 2. Okay, so we have got a upon, this is your pi n common. Okay, pi n I am taking common, and 2 also, j I am leaving it. So when we put 1, you will get, when we put 1 we will get e to the power minus j pi n, and when we put 0 it is 1, we are getting minus j. Minus minus become plus. Okay, this minus I have taken, and e to the power minus j 2 pi n. Okay, so that is 2 pi n, and then minus of e to the power minus j pi divided by what, j. So the value of j 2 pi n is 1, so the value of this is 1, the value of this term is 1. So here 1 by j and here minus 1 by j we are getting. And minus j pi n both will be added. I think yes. Okay, now tell me, e to the power minus j pi n, if I take this minus sign here, if I take this minus sign here, then it is becoming plus, and when it is becoming plus, it is actually cancelling, na? Not cancelling. Okay, not cancelling at all. Now if I put, let's say, a upon 2 pi n. Okay, now if I separate it, e to the power minus j pi n divided by minus j, and this is plus 1 by j, this is also plus 1 by j, and this is e to the power minus j pi n divided by j. Okay, so we can write it as, if I am writing it here, okay, I am writing it here. So a upon 2 pi n is, both are minus sign, this is minus 1 by j, minus 1 by j, so this is 2 times e to the power minus j pi n divided by j with the minus sign, and this is plus 2 times of j. Okay, so this 2 and 2 will also get cancelled, so we will get a upon pi n j also I am taking common, and this 2 we have cancelled, this 2 and 2 we have cancelled, so we have got 1 minus e to the power minus j pi n. Okay, and then finally, we are not able to see here, so this is, what is the e to the power minus j pi n? Minus 1 to the power n divided by pi n into j whole multiplied with a. So according to the options, a upon j and pi, a upon j and pi we are getting, and in between them we are getting minus sign. Okay, so in between them we are getting minus sign, that means option C is the right answer. Okay, Ishwar, now you have got the answer, option C. Option C will be the right answer. We have used the simple formula. Just the calculation. The calculation is important. Only option C, you have to clearly see that option C is matching. Okay. So I hope you are not able to see that. Okay. Now solve this one. Yes. So here in this particular question, we have to calculate the image rejection ratio. So what is the image rejection ratio? That image rejection ratio is option C you are getting. Yeah, calculation is required, but answer is not correct. Image rejection ratio is given as 1 plus q square into rho square. Okay. So what is rho? The rho is nothing but the F image, that is the image frequency, divided by the radio frequency minus radio frequency divided by image frequency. So to get this value, we have to calculate the image frequency first, because here it is nothing is given. So we will calculate the image frequency by default, that is the radio frequency plus 2 times of intermediate frequency. So the radio frequency is, what is the radio frequency? The radio frequency is nothing but a 500, okay, and 2 times of intermediate frequency, which is 465. So after solving this, what you are getting, 1430 kilohertz you are getting. So 1430 kilohertz you are getting, right? 1430 kilohertz you are getting. Now we will substitute these values. So this is 1430 divided by 500 minus 500 divided by 1430. Okay, so when you calculate this, we are getting 2.51 something, right? Ishwar, 2.51. So image rejection ratio would be root over 1 plus q square is 30 whole square into 2.51 whole square. Okay, 30 whole square and 2.51 whole square. So it is equal to 75.31. 75.31 we are getting. So answer is option B. Option B will be the right answer. Next question, question number 87. Now solve this. Wait a second, guys. I think there is a problem. I think you are getting now. Option A. Yes, so this time you have got the right answer. The modulation index for the frequency modulation is given as maximum frequency deviation divided by massive signal frequency, and maximum frequency deviation is kf into am divided by massive signal frequency. So what is the value of kf? The value of kf is 3000. And what is the value of am? The value of am is 2. So divided by fm, what is the value of massive signal frequency? That is 1000. So we are getting the value as 6. Now for the phase modulation also we have the same formula, that is kp into am upon fm into kp am fm, and this fm and fm will get cancelled, and this is kp into am for the sinusoidal signal. So here the kp is your 3000 and am is 2, so we are getting 6. Sorry, kp is 1.5. Sorry, just second. kp is 1.5, am is 2, so this is 3. So the 6 and 3 will be the right answer. Yes. Nice stickers you are using, Manasvi. Yes. Now answer this question. And I am giving you 2 minutes for a Options are A 3 upon n naught, B 6 upon n naught, C 9 upon n naught, and D 12 upon n naught. Okay, the two options are maybe not visible. So 3, 6, 9 and 12 in the numerator, and then in the denominator is n naught. So 30 seconds left. Yes, so this time you are wrong. Not 12 upon n naught. The maximum signal to noise ratio in case of the match filter is given by 2 times energy of the signal divided by n naught. Now you just need to calculate the energy of the signal. So what is the energy of the signal? The important point here is to just calculate the energy of the signal. So energy of the signal is given by integration from the time period, or you just write the formula first, minus infinite to infinite s of t mod square dt, right? So here the signal is 0 to 1. What is the value of s of t? The value of s of t is y is equal to mx plus c when you will apply. Then the slope is 3 and the axis is t. So this is 3t, and intersection with the y-axis is 0. So this is 3t plus 0. So you are getting 3t. So the signal is 3t. So this is 3t whole square and dt. So you are going to get 9 and t square, that is t cube by 3, that is the integration, and from 0 to 1. So 0 to 1 it is, you are getting 3 only. So you are getting 3. So energy of the signal is 3. So 2 into 3 divided by n naught. So the value is 6 upon n naught. So the correct answer is option number B. Yes, option B is the right answer. Okay, option B is the right answer. Now solve this. A data with a rate of 500 kbps is to be transmitted using the BPSK modulation. If the baseband modeling of the data is done by a raised cosine filter with a roll-off factor of 0.5, then the minimum channel bandwidth required to transmit the BPSK modulated signal will be. So for BPSK, the bandwidth is given by 2 times of RB. Okay, but with the raised cosine, the bandwidth is RB is replaced by RB by 2 1 plus alpha. So when you replace RB by 2 1 plus alpha, this is the RB into 1 plus alpha. So what is the bit rate? The bit rate is given as 500. So bit rate is 500. The alpha is 1.5, 0.5. The alpha is 0.5. So it is 750 kilohertz. Yes. Now the correct answer is option C, 750 kilohertz. Now answer this question. Yes. So this is a good question, na? So here in this question, a spectrum of 1000 to 1650 kilohertz is assigned for the DSB-SC AM transmission. The spectrum is paired for the different user using the FDM and the quadrature carrier multiplexing. Okay, so it is repeated 2 times. So quadrature carrier multiplexing. If each user has a message bandwidth of 5 kilohertz, then the maximum user number of user can be simultaneously transmitted. So because we are using the AM, first thing that you have to understand that we are using AM. So in the AM, the bandwidth requirement will be twice of the message signal frequency. So message signal bandwidth is 5. So we need a 10 kilohertz bandwidth to transmit one AM signal. And the number of user if you want to calculate. So number of user, because you are using the quadrature carrier multiplexing. So in the single bandwidth, you can transmit the two signals. So that is why I am multiplying the two, and the range is 1650 minus 1000 divided by the bandwidth. So you can see that this is nothing but a 2 into 650 divided by 10. So 650 into 2 is 130. So 130 will be the right answer. Okay, remember that this 2 I am using because of the quadrature carrier multiplexing. Because of the quadrature carrier multiplexing, using this 2 FM bandwidth, you can transmit the two signals simultaneously. So the single bandwidth is transmitted by the in the single bandwidth we are transmitting the two signals. So we can say that we have the overall using the bandwidth of 5 only. Yes. Now solve this one. Okay, now the output of the information source consists of 128 symbols, 16 of which occurs with a probability of 1 by 32, and the remaining 112 occur with a probability of 1 upon 224. Then they emit the 1000 symbols per second. We have to simply calculate the information rate. That information rate is I is equal to R into H, or we can write R is equal to small r into H. So small r is 1000, H is your entropy. So entropy is nothing but a probability, okay? Probability log base to 1 upon probability. So how many symbols are there? 16 symbols. So 16 symbols is having the probability 1 upon 32 log base to inverse of the probability. Then 120 symbols are having probability 1 upon 224 and log base to inverse of probability, that is 224. So in this way we will get all, when after all the calculation we are going to get the 6.4. Okay, 6.4 kbps. This is 6.4 kbps. Answer is option A. Just you have to do the calculation. Now coming to the next question. Solve this. Now you can write this MT as, in terms of sine, this is sine 1000 pi t divided by 1000 pi t whole square. Okay, so from here you can also write it as 1 minus cos 2000 pi t divided by 2 into 1000 pi t whole square. Okay, so from here you can see that the message signal is having the frequency 1 kilohertz and the AM signal is required. So AM signal requires the bandwidth of 2 times of FM, that is 2 kilohertz. Now no need to use the Carson rule, it is AM. This is AM, so no need to use the Carson rule. Okay. Now answer this question. In a TDMA based cellular system, each frame consists of 8 time slots and each time slot contains 156.25 bits. If the data is transmitted at the rate of 270.833 kbps, then the duration of the frame is. Yes. So now you can see that each bit is having each slot is having 156.25 and the bit rate is given that 270. So the time bit duration, you would say, bit rate inverse is nothing but a bit duration. So bit duration is 1 upon bit rate. Okay, 1 upon bit rate. So what is the bit rate? This is 1 upon 270.833 into 10 to the power 3. So when we will calculate it, so it is approximately coming as 3.692 microsecond. Okay, now this is the bit duration. This is the bit duration. Now what we have to do? Each slot is having 156.25 bit. So the slot duration, let us say T slot, the slot duration is 156.25 bits multiplied with 3.692. Okay, so when you will solve this, you will get 577 microsecond. Now the frame, each frame is having how many slots? Each frame is having the 8 time slots. So this is 8 into time slot. So 8 into 577 microsecond. Okay, so when you will calculate it, you will get 4.615 millisecond. So answer is option C. Okay, now coming to the next one. Solve this. Okay. So now, as when you compare this particular signal with the standard AM signal, it is nothing but the AC into MA by 2 cos omega C minus omega MT, and then it is AC cos omega CT plus AC MA by 2 cos omega C plus omega MT. Okay. Now using this relation, if you compare this, you are getting AC is equal to how much? 20, and AC into MA by 2 is equal to 5. So from here you can see that it is nothing but the modulation index equal to how much? 0.5, and modulation index is 0.5, and we know that the modulation index is given as K into AM. So it is equal to 0.5. The value of K is given as 0.5. So the message signal is having the amplitude AM. Okay, so the message signal is having the amplitude AM, that's correct. So these two options are eliminated. Message signal is having the amplitude AM. Now if you also compare, the omega C is 2000. So what about the omega C plus omega M? If you compare these two terms, so it is 2200 2000 pi. So this is 2200 pi. So what is omega M? So this is 2200 pi minus 2000 pi equal to 200 pi. So the omega M is 200 pi. So this is the correct answer, 200 pi, cos 200 pi. So the amplitude is 1 and omega M is 200 pi. So these two things are required to get the answer. Yes. Now it's time to drink the water. Now solve this one. This one can be told by anyone. It is the easy one. So what about the path loss? The path loss is given by 4 pi r upon lambda whole square. So from here you can see that, no, 4 pi r upon lambda whole square. So if we increase the value of r, the path loss also increases. So here we are talking about the lower earth orbit. So lower earth orbit means that we are decreasing the value of r. Low earth orbit means the range is less. So if the range is less, the path loss will be low. So path loss will be low. What is the answer of this question? The power amplifier in the satellite which is used, this is TWT, because the power handling capability of the TWT is good, so that is why we have the TWT in the power amplifier. Okay. Now what about this one? A fiber has the refractive indices, core indices is 1.47 and the cladding indices is 1.46. So the minimum angle at which the ray will strike the core cladding interface to guide it in the core is, yes, to guide it in the core. We have 3 questions left, guys. So quickly answer these 3 questions. Eighty-three. 83.3, yes, 83.3 is the right answer, because we want to calculate the critical angle. So critical angle is sin inverse the refractive index of cladding divided by refractive index of core. So sin inverse of cladding is 1.46 and the core is 1.47. So when you will calculate it, it is 83.3 degree. Good. Now what is the answer of this question? Yes. So optical communication system uses the avalanche photodiode. Okay. So it uses the avalanche photodiode. So in this question, suppose I want to calculate the acceptance angle, then what should be the acceptance angle in this question? Can anybody tell what should be the acceptance angle in this question? What should be the acceptance angle in this? Sin theta? No. Acceptance angle is theta A is equal to sine inverse of numerical aperture. So sine inverse of numerical aperture, what is the numerical aperture? Numerical aperture is given as n1 square minus n2 square. So this is how you can calculate the acceptance angle. Now answer this one. Yes, intermodal dispersion, correct. Intermodal dispersion will be the right answer, because as you can see that it is in this question, it is asking a single mode fiber does not suffer from which type of dispersion. So this is a single mode and it is intermodal, that means it is having the multi-mode. Intermodal exists in the multi-mode. Intermodal means between the two modes. So between the two modes, if there is a dispersion, that means definitely there will be more than one mode, and if there will be more than one mode, then definitely there will be intermodal dispersion, not the other dispersion. Like this is the single mode dispersion, single mode fiber. So single mode fiber is having only one mode. So in the single mode, we don't we have the waveguide dispersion, we may have the material dispersion, we may have the polarization dispersion, but we cannot have the intermodal dispersion. Yes. Now, what is the answer of this question? Okay, anyone else who wants to answer? Yes. So you both are getting the right answer. The answer is option D. Why are the semiconductors important for the communication engineering? So they possess the large bandwidth, they operate at low voltage, they are suitable for the coupling to the fibers at the wavelength where the attenuation is very small, and their integration with the other components is also easy. Right? So all the four statements are correct about the lasers. So I think now you have got all the 100 questions, 100 technical questions. So anything would you like to ask about this HAL examination? Remember that there are certain topics which are very, very important for HAL. Let me give you the name of those topics. So in the HAL, the important topics for the different subjects are, if I talk about the engineering mathematics, so don't leave this engineering mathematics. So in the engineering mathematics, you can follow uh, the eigenvalue problems, eigenvalue, eigenmatrix, eigenvectors. Okay, and some series problems like Taylor series. These are important topics that you have to study. In the analog, and EDC, the important topics based on the previous year questions are half wave rectifier, okay, MOSFET amplifier. You can also get the questions from the filters. You can also get the question from the PN junction diode. Okay, so these are the important topics. If I talk about the digital circuits, then in the digital you are going to get the questions from the flip-flop latches, multiplexer, okay, so Boolean algebra, number system, etc. And if again I talk about the communication, you will get the question from AM, PCM, quantization, information theory. These are the important topics that you should study. And the rest of this are what are the different subjects like control system. In the control system, you will get the stability, Routh-Hurwitz stability. You will get the polar plot. Okay, the compensators, the questions from the compensator, that which are lag, maximum angle, etc. Then if network theory, you will get the question from two ports and the transient. Yes, and what about the EMFT? You are going to get the antenna questions. Okay, and what subject left? 3, 4, 5, 6. Which subject we have left? 3, 4, 5, 6, 7. One more subject we left now. Which subject we left? Digital. Smith chart. Oh, it's a Smith chart. We cannot say. It may come, it may not come. I am saying about the based on the previous year paper. Signals and system. Yes, the signals and system we have left. So the Laplace transform, the Laplace and the Fourier transform. So these are the topics which are important for your ISRO examination based on the previous paper answer. Okay, based on the previous year paper. By the experience of the students, those who have appeared in the previous year HAL exam, they told me these topic names. So obviously all the topics cannot be remembered by them, but the topic name which they have told, I have also mentioned over here. Now don't forget to register yourself. If suppose you have not registered for the full-time course of GATE 24, then you can register yourself, and the test is going to be open. The window will be open from 9 AM to 9 PM every Sunday, that is 6th August, and then coming Sunday. There is a very good workshop, interactive workshop by our faculties like Rakesh sir and Dhiraj sir on 8th of August, 7:30 PM on the A Topper's Blueprint to Success in the GATE 24. Yes. Okay, so thank you for watching this session, guys. We will meet again with another session of HAL and ISRO. So don't forget to subscribe the channel if you have not subscribed it yet. And also one more thing, download the BYJU'S Exam Prep app to get the free classes on the different examination, because we cannot take the every classes on the YouTube. So sometimes we take the classes on the app also. So you will get the content in the app also. So don't forget to download the app on BYJU'S Exam Prep. And today I have the class on BYJU'S Exam Prep 8:15 PM. Thank you.